I am Balaji Rao. Welcome to BR Max class. This is first class on sets chapter. First, I'll recall all the synopsis one after another. Once completion of all the synopsis, then we'll start objective bits. Okay. So the first point is, what is set? A well-defined collection of objects is called a set. Here you need to observe two words. First one is well-defined and second one is objects. What are known as objects? In mathematical language, all the things which is either living or non-living are known as objects. A well-defined collection of objects is called a set. Well-defined. We'll try to understand what is this well-defined collection of objects. Objects means what? Object means things which are either living or non-living. Well-defined collection of objects. We'll try to understand what is this well-defined with few examples. Collection of vowels in English alphabet is a set or not? Collection of vowels in English alphabet. Vowels in English alphabet are well-defined or not? What are the vowels in English alphabet? What are the vowels in English alphabet? Everybody knows that A, E, I, O, U are the vowels in English alphabet. So, collection of vowels in English alphabet. What the point is, vowels in English alphabet is well defined or not? Yes, vowels in English alphabet is well defined. So, collection of vowels in English alphabet is a set. It is a set. Now we will try to understand this with one more example. Collection of all natural numbers. Natural numbers. Natural numbers are well defined or not? What are the natural numbers? 1, 2, 3, 4 like that. All those are natural numbers. So natural numbers are well defined or not? Yes, natural numbers are well defined. So collection of all natural numbers is a set or not? Yes, it is a set. We'll try to understand this with one more example. You observe this collection of all beautiful girls in a class. You observe this beautiful girls in a class. Collection of beautiful girls in a class. Here the point is, this beautiful girl is well defined or not? If we consider a particular girl, that girl may be beautiful to you. The same girl may not be beautiful to your friend. So, beautiful girl is not well defined. This word beautiful girl, good girls, those things are not well defined. So, collection of beautiful girls in a class is not a set. Now, we will try to understand this with one more example. You observe here collection of good teachers in a college. Good teacher. Suppose a particular teacher, you may feel that that teacher is good. The other person may not feel that the same teacher is a good teacher. So good teacher, the word itself, it is a vague term. It is not well defined. Good teacher is not well defined. So collection of all good teachers in a college is not a set. Why it is not a set? Because good teacher is not well defined. A particular teacher may be your favorite teacher. The same teacher may not be favorite to your friend. So, good teacher is not well defined. I hope you understand the definition of set. Now, we will learn important note related to this definition. See, here objects in a set are called elements. Objects in a set are called elements. For example, you see this collection of all natural numbers is a set. So here what are the objects? Natural numbers are the objects. 1, 2, 3, 4 like that. So all those objects are objects in a set are called elements. So 1 is element in this set. 2 is element in this set. Like that, objects in a set are called elements. And second point is, in general, sets are denoted by capital letters A, B, C. And elements are denoted by small letter A, B, C. Now the second synopsis is representation of a set. How we represent a set. First method is roster method. Roster method is also known as tabular method. Second method is set builder method, which is also known as rule method. First, we will try to understand what is roster method. In roster method, all the elements of a set are listed and they are separated by commas within curve brackets. What is roster method? In roster method, all the elements of a set are listed and separated by commas within curved brackets. We will try to understand this with two examples. First example, we know that collection of vowels in English alphabet is a set because vowels in English alphabet are well defined. How we represent this set in roster method? How we represent this set in roster method? What is roster method? In roster method, all the elements of a set are listed. And here what I will do now, I will list all the elements of this set. What are the elements of this set? Vowels in English alphabet. You list A, E, I, O, U. All the elements of a set are listed and separated by commas. Okay, you separate them commas within brackets. So you observe here, all the elements of this set are listed and separated by commas within the brackets. So this is known as roster method, roster representation of a set. We know that generally sets are represented by capital letters. So I can write this set like this. This type of representation is known as roster method. Roster method is also known as tabular method. We will try to understand this with one more example. Collection of prime numbers less than 5. We know that prime numbers are well defined and they are clearly saying that less than 5. So this is a set or not? Collection of prime numbers less than 5 is a set or not? Yes, it is a set. So how we represent this set in roster method? What is roster method? In roster method, all the elements of a set are listed and separated by commas within the brackets. So you list all the prime numbers which are less than 5. What are the prime numbers which are less than 5? 2, 3. Prime numbers less than 5 are listed and separated by commas within brackets. So this is representation of this set in which method? Roster method. Generally sets are denoted by capital letters, so this set I can represent like this. So this type of representation of a set is known as roster method, which is also known as tabular method. Now we will try to understand what is set builder method. Set builder method. In this method, all the elements of a set are represented by with its single common property. All the elements of a set are represented by with its single common property. We will try to understand how we represent a set in set builder method by using an example. I'll consider the same example what is there here. You observe collection of vowels in English alphabet. Here this type of representation is known as roster method. Now how we represent same set in set builder method? See, I'll take this set as A. How we represent? We represent like that. X says that what is the common property? X is a vowel in English alphabet. You observe here, all the elements of this set are like X. What is X? X is a vowel in English alphabet. So this is the representation of this set in set builder method. You observe here, I consider the example collection of prime numbers less than 5. You see here same example I taken. Here this is the representation of this set in roster method. How we represent the same set in set builder method? We represent all the elements with its common property. It is an element like X. What is X? X is a prime number. X is prime number, and what you will say about X? X is less than 5. What happened? Here all the elements of this set is represented with its common property. So in this way we represent a set in both the methods. I hope you understand what is roster method and what is set builder method. Till now we learned about definition of a set and how we represent a set. Now we will learn types of sets. In types of sets, first we will learn about empty set. Empty set is also known as null set and it is also known as void set. What is empty set? A set which has no element is called empty set. A set which has no element is called empty set. Empty set is also known as null set. And this null set is denoted by like this. Phi, phy, phi, r, we'll write just simple empty brackets and we won't write anything here. So we will learn about empty set. What is empty set? A set which has no element is called empty set. Null set is denoted by phi, or simply we'll write only brackets, we won't write anything in between them. And we'll try to understand this null set with an example. You observe this example, collection of months in a year which are having 32 days. We know that in a year 12 months are there. You please tell the months which are having 32 days. You please tell the month which are having 32 days. We know that we don't have any month which is having 32 days. So collection of months in a year which are having 32 days is a null set because we won't find any element in this set. Now fourth synopsis in this sets, that is singleton set. What is singleton set? A set having only one element. A set which is having only one element is called singleton set. For example, you see this is the set having only one element. We say that this set is a singleton set because it is having only one element. Now fifth synopsis in this sets is finite set. What is finite set? A set which consists finite number of elements is called finite. A set which consists finite number of elements is called finite set. We'll try to understand this with an example. You consider a set A like this, 1, 2, 3, 4. How many elements present in this set? Finite number of elements or infinite number of elements? Finite number of elements are present. So this set is known as finite set. And we'll take one more example. Collection of all vowels in English alphabet. What you will say about this set? This set is a finite set or infinite set? We say that this set is finite set because it is having finite number of elements. How many elements are present in set B? 5 elements are present. So what is finite set? A set which consists finite number of elements is called finite set. Important note related to finite set. Empty set is treated as finite set. So you need to remember this. Empty set is finite set or infinite set. If someone asks, we need to say that it is a finite set because it consists no element. Right? So empty set is treated as finite set. Infinite set. What is infinite set? A set which consists infinite number of elements is called infinite set. A set which consists infinite number of elements is called infinite set. We can understand easily this with an example. I'll consider collection of all natural numbers. 1, 2, 3, 4 like that, all the natural numbers. How many elements present in set A? Infinite number of elements present in set A. That's why this set is known as infinite set. Similarly, if I consider collection of all prime numbers 2, 3, 5, 7 like this. Collection of all prime numbers is a finite set or infinite set? You observe here how many number of elements are present in set B. Finite number of elements or infinite number of elements? Infinite number of elements present in set B. So these are the examples for infinite. This is the seventh synopsis. Here we will learn what is subset. We will learn the definition of subset, few examples to understand subset, and 5 important points related to subset. First, we will try to understand what is the definition of a subset. Let A, B are any two sets. You consider two sets A and B. If all the elements present in set A, that means every element present in set A are present in set B. All the elements present in set A are present in set B, then A is called subset of, which is denoted by A is subset of B. We'll try to understand this with example. You observe here, I consider a set A is equal to 1, 2, 3. Now, I'll try to write all the subsets of A. I'll consider a set like this. You observe all the elements present in this set are present in A. Yes, this set contains one element, that is 1. That element is there in this set? Yes. So this A1 is subset of A. Similarly, you observe this set A2. All the elements present in this set are present in A? Yes. So this is subset of A. All the elements present in A3 are present in A? Yes. So this is subset of A. I'll write few more subsets of A. You observe the set A4. This set contains two elements, 1, 2. All the elements present in this set are present in A? Yes. So A4 is a subset of A? Yes, A4 is subset of A. Here, few important points you need to observe. Empty set is treated as subset of every set. You observe here this set, this is the empty set. Is empty set is subset of A? Yes. We say that empty set is subset of every set. You need to remember this point. Empty set is subset of every set. Now, I'll write one more, that is a 8th set. You observe this set, is it is a subset of A? Yes, of course, all the elements present in set A8 is present in set A. So, every set is subset to itself. You observe here, whatever the sets I written here, all are subsets of A. Now we will learn important note related to subset. First point, you see, whenever A is subset of B, whenever A is subset of B, then B is called superset of A. You observe this A1 is subset of A? Yes, the set A1 is subset of A. Here we say that A is superset of the set A1. I hope you understand. If set A has M elements, then number of subsets of A. How many subsets we will get for set A? We will get 2 power M subsets for set A. You observe here how many elements present in this set? 3 elements present. How many subsets we will get? 2 power M. Here M is 3. 2 cube is what? 2 cube is 8. So here how many subsets we got for set A? We got 8 subsets for set A. So what is the second point related to subset? If set A has M elements, then number of subsets of A equal to 2 power M. This is the important point you need to remember. And it is important point. Empty set is subset of every set. Please keep this point in your mind. Empty set is subset of every set. Next point. Every set is subset to itself. Every set is subset to itself. These 2 points you need to remember. Empty set is subset of every set and every set is subset to itself. Last note related to subset. If A is subset of B and B is subset of C, then which is written as, we can write it as A is subset of B. All the elements present in A are present in B, all the elements present in B are present in C, then directly we can write A is subset of C. This can be understood very easily. 8th synopsis is proper subset. What is proper subset? If A is subset of B and A is not equal to B, then A is called proper subset of B, which is denoted like this. You observe here, I am not writing like this. Generally subset means we will denote like this. But I am strictly subset. A is just the subset of B, but A is not equal to B. Then A is called proper subset of B. We will try to understand this with an example. You observe the set S. The set S is 1, 2. Now, how many subsets we can write for set S? This we learn in subset. How many subsets we can write for set S? As set S is having 2 elements, number of subsets of set S is 2 square. So here I written all the subsets of set S. You observe, is A1 is subset of this set? We know that empty set is subset of every set. Is A1 is proper subset of S or not? Of course, it is a subset of S and A1 is not equal to S. So what we say here, this is a proper subset. Okay. You see this A2. A2 is subset of S or not? Yes. A2 is a subset of S. Is A2 is same as S? No. So it is satisfying proper subset condition or not? It is a proper subset. It is a proper subset. Proper subset of what? Proper subset of yes. It is a proper subset of yes. Yes, it is a proper subset of yes. And you see similarly, this is also proper subset of yes. And what about this A4? You observe this set. Is A4 is subset of S? We know that every set is subset to itself. So here A4 is subset of S because all the elements present in A4 are present in S. Is A4 is same as S? Yes, A4 is same as S. But actually what is the definition of proper subset? If A is a subset of B and A is not equal to B, then A is called proper subset of B. Here the point is it is a subset of S, but here the point, these two are equal. So is not a proper subset. It is not a proper subset. Now we will learn important note related to this proper subset. You observe here, if set A has m elements, set A has m elements, then number of proper subsets of A. How many proper subsets will be there for set A? The formula is 2 power m minus 1. You observe here, this is the set S. For this, how many proper subsets we got? 1, 2, 3. 3 proper subsets. See here, 2 square, total number of subsets minus 1. 2 square is 4. 4 minus 1 is 3. So if set A has m elements, how many proper subsets we will get for set A? 2 power m minus 1. Cardinal number of a set. What is meant by cardinal number of a set? See here, the number of distinct elements. Distinct elements means different elements present in the finite set, present in the given finite set A is called cardinal number of set A, which is denoted by n of A. We'll try to understand this with an example. You observe here, I consider two finite sets. What is the cardinal number of set A? Cardinal number of set A is denoted by n of A. The number of distinct elements present in a finite set. How many elements present in this set? In this set, 3 elements are present. So n of A, cardinal number of this set is 3. What is the cardinal number of set B? How many elements present in this set B? 1, 2, 3, 4, 5. Total 5 elements are present. So cardinal number of set B is 5. Now 10th synopsis is equivalent sets. You observe here, it is equivalent sets. Equal sets is different, equivalent sets are different. What is meant by equivalent sets? See here, two finite sets A comma B are said to be equivalent if cardinal number of set A is same as cardinal number of set B. We will try to understand this with an example. You observe the sets here A and B. What is cardinal number of set A? Cardinal number of set A is 4 because 4 elements present in set A. What is cardinal number of set B? Set B cardinal number is 4 because 4 elements are present in set B. As cardinal number of set A is same as cardinal number of set B. If cardinal number of set A is same as cardinal number of set B, then we say that the sets A comma B are equivalent sets. Power set. What is power set? The set of all subsets of a given set A is called power set of A. You observe here, all subsets of a given set A. All subsets of a given set A is called power set of A. Power set of A is denoted by P of A. We will try to understand this with an example. You observe here, I considered a set which consists 2 elements 1, 2. First, I'll write all the subsets of A. What are all the subsets of A? We know that empty set is subset of every set and every set is subset to itself. These two are the subsets of A. And you can observe that this set is subset of A and this is subset of A. I written all the subsets of A. What is the definition of power set? The set of the set, you observe here, I'll write set. Try to understand. This is the set of all subsets of A is called power set of A, which is denoted by P of A. I hope you understand. You observe here, if set A contains 2 elements, its power set contains 4 elements. So if set A contains m elements, then number of elements in P of A equal to 2 power m. Suppose if set A is having 3 elements, then power set of A contains 2 power 3, that means 8 elements. I hope you understand power set. Now 12th synopsis is universal set. What is universal set? Universal set, a set which consists all sets or elements. Please try to understand. A set which consists all sets or elements under consideration is called universal set. Universal set is denoted by U. We'll try to understand this with an example. You observe here 4 sets are there. Set A contains elements from 1 to 9. Set B 3, 4, 6, 7. Set C 1, 9, 7, 6, 3, 2. Set D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You observe here we consider 4 sets. Under this consideration, a set which consists all the elements or all the sets under consideration is known as universal set. Which set is known as universal set for given sets ABCD? Which set we treat it as universal set for these 4 sets? You can observe the set T. This is the set which consists all the elements under the consideration. You observe the set D. All the elements present in A are present in D. All the elements present in B are present in D. All the elements present in C are present in D. So what you identified? The set D consists all the elements under consideration. Therefore, D is the universal set in this consideration. Operations on sets. First operation is union of 2 sets. First, we will learn how union of 2 sets is defined. The union of 2 sets A comma B. Union of 2 sets A comma B is denoted by A union B. Look here, how we read this as? We read it as A union B. And how it is defined? A union B is defined as all the elements which are either in A or in B or in both A and B. That means A union B contains all the elements which present in either A or in B or in both A and B. We'll try to understand this with an example. You observe here I consider 2 sets A, B. Now we need to calculate A union B. How A union B is defined? A union B is defined as all the elements which are either in A or in B or in both A and B. You observe one is there in A, so we will write here. If the element present in A or present in B, then it will be in A union B. 2 is there in A, so it comes in A union B. 3 is there in A, so it comes in A union B. You observe 4 is there in both A and B. Elements which are present either in A or in B are in both A and B. So even though 4 is there in both the sets, it comes in A union B. See 5 is present in B, so it present either in A or in B. Next 6. So in this way we will calculate A union B. Now we will learn very important note related to union of sets. We will try to understand what is A union B in Venn diagram. Which zone is known as A union B in this Venn diagram? You observe this first circle is set A, second circle is set B. Where is the zone which is A union B? If you observe in this diagram, total 4 parts are there. This is first part, this is second part, and this is third part, and other than these circles outside is the fourth part. Please try to understand. First part, second part, third part, fourth part. What is the fourth part? Other than these circles, what is there in this rectangle box other than this area? That is the fourth part. What is A union B? A union B contains all the elements which are either in A or in B or in both A and B. So the part 1, 2, 3 will be A union B. You try to understand this zone 1 and this zone 2 and this zone, this full zone. So this full is A union B. The part 1, part 2, part 3. This full zone is what? This is A union B. So the shaded part is the region of A union B. Now second important point related to union of sets. How we represent union of sets in set builder form. How we represent union of 2 sets in set builder form. X is the element present in A union B such that we write it as X belongs to A or X belongs to B. A union B in set builder form we can write like this: X belongs to A or X belongs to B. Third point, A union A. When we calculate A union A, what you will get? Can you guess what we will get? A union A. A union A is A only. Fourth important point. What you will say about A union B and B union A? Are they equal or they are not equal? What you say about A union B and B union A? Is A union B is same as B union A? What is B union A? B union A is the set which contains the elements which are present in B or in A or in both A and B. So here we can easily understand that in sets A union B is same as B union A. When we union with universal set, when we do union with universal set, A union universal set, which set we will get? We know that universal set is the set which contains all the sets or elements under consideration. So as universal set is the bigger set, when we do the union, bigger set will be the answer. So A union universal set is universal set. A union null set. Null set is empty set which consists no element. In these two sets, which set is the bigger set? A is the bigger set. So when we do the union, we will get bigger set. So A union empty set is A. In sets, associative law holds good with respect to union. A union B union C is same as A union B union C. You need to remember these points which will be useful while solving the problems. A union B union C is same as A union B union C. This is known as associative law with respect to union of sets. Last point. If A is subset of B, that means all the elements present in A are present in B, then what is A union B? Here you need to observe one thing. In A and B, which set is the bigger set? A is subset of B means all the elements present in A are present in B. Here we can easily understand that B is the bigger set. So when we do their union, we will get the bigger set. So A union B is B. So this is all about union of two sets. Next, we will learn intersection of two sets. Next, 14th synopsis is intersection of two sets. What is intersection of two sets? Intersection of two sets A comma B is denoted by A intersection B. Like this. How we read it as? A intersection B. Intersection of two sets A comma B is denoted by A intersection B and is defined as all the elements which are present in both A and B. It is not like union of sets. What is about union of sets? All the elements which are present in A or in B or in both A and B. But here in intersection of sets, we will consider the elements which are present in both A and B. We can understand this with an example easily. Here you observe two sets are there, A and B. A intersection B. What is A intersection B? How it is defined? All the elements which are present in both A and B. You observe the elements which is present in both A as well as in B also. One is there in A, one is not in B. 2 is there in A but it is not in B. 3 is there in A but it is not in B. You observe 4 is there in A and 4 is present in B also. So what are the elements which are common in both A and B? That comes in A intersection of B. Is there any other element which is common in both? No. 4 is the only element which is present in both A and B. So A intersection B is the set 4, singleton set 4 you will get. Now we will try to understand what is intersection of sets more clearly by using Venn diagram. You observe here, I consider two sets A and B, and this box we treat it as universal set. If you observe this box, total 4 parts are there in this. This first part, and this is the second part, and this is the third part. Other than these circles, whatever the remaining part is there, that is the fourth part. Now in this diagram, which zone is known as intersection of two sets? What is intersection of two sets? All the elements which are present in both A and B. You identify the elements which are present in both A and B. You see here, this is the zone, this zone present in A and this zone present in B also. Please try to understand. This is the zone which is present in A and which is present in B. That means second part is the intersection of two sets in this Venn diagram. Now second important point, how we write A intersection B in set builder form. X is an element which is present in A intersection B such that X belongs to A and X belongs to B. In union, what we written? A union B is written as X belongs to A or X belongs to B. When we calculate A intersection A, what we will get? When we calculate A intersection A, we will get A only. You can observe that when we calculated A union A, at that time also we got A. When we do A intersection A, then also we will get A. Okay. Next, fourth point. What you can say about A intersection B and B intersection A? Is A intersection B is same as B intersection A? What you will say about A intersection B and B intersection A? A intersection B means all the elements which are present in both A and B. B intersection A means all the elements which are present in both A and B. We can easily understand that those two are equal. A intersection B is same as B intersection A. A intersection null set. Here you try to remember this. When we do union of two sets, we will get the bigger set. When we do intersection of two sets, we will get the smaller set. Here A is a set and phi is the empty set. We know that empty set is subset of every set. In these two sets, which set is smaller? So intersection of these two is empty set. A intersection empty set is empty set. A intersection universal set. Universal set is the set which consists all the sets or elements under consideration. In these two sets, which one is the smaller set? Obviously, the set A is the smaller set compared to universal set. When we do the intersection, we will get the smaller set only. Okay, so A intersection universal set is A only. What about associative law with respect to intersection? With respect to intersection, associative law holds good. That is, A intersection B intersection C is same as A intersection B intersection C. Associative law holds good with respect to intersection. We know that associative law holds good with respect to union also. Last point in intersection of sets. A is subset of B, then what you will say about A intersection B? If A is subset of B, then which set is the smaller set? If A is subset of B, A is the smaller set. When we do the intersection, we will get the smaller set only. You remember, when we do their union, in case if we write about union, A union B, we will get the bigger set. If A is subset of B, B is the bigger set. When we do their union, we will get bigger set. When we do their intersection, we will get the smaller set. This is just a trick to remember these formulas. I hope you understand about intersection of two sets. Now, 15th synopsis is disjoint sets. Two sets A, B are said to be disjoint if A intersection B is null set. That means if no element is common in both the sets, then we say that those two sets are disjoint. We will try to understand this with an example. I will consider a set A like this: 2, 4, 6, 8. And the set B is like this: 1, 3, 5. Are these two sets are disjoint? When we say two sets are disjoint, when we calculate their intersection, if their intersection is null set, then we say that the sets are disjoint. Calculate A intersection B. How we will calculate A intersection B? The elements which are common in both A and B. You identify any common element present in both A and B. There is no element common in both A and B. Here A intersection B is a null set. So what we say, therefore the sets A comma B are disjoint. Therefore the sets A comma B are disjoint. The difference of two sets A comma B is denoted by like this, A minus B, like this, or A by B. What it is a notation of difference of two sets. Generally we use this notation. Difference of two sets A comma B is denoted by A minus B. And A minus B is defined as all the elements present in A but not in B. What is A minus B? A minus B is defined as all the elements which are present in A but not in B. We will try to understand this with an example. You observe here, I consider two sets A and B. And what is A minus B? A minus B means all the elements which are present in A but not in B. You observe here, this is the element present in A but it is not present in B. Now you come to the second, B. B is element present in A. B is in set B? No. So we'll write like this. Now what about C? C is element present in A. It is present in B also. But what is A minus B? All the elements present in A but not in B. Okay. So here D is present in A. D is present in B also. So A and B are the only elements which are present in A but not in B. I hope you understand how we calculate A minus B. Now we will try to understand this more clearly with Venn diagram. Okay, you observe here, I consider the sets A and B. A minus B, I need to identify in this Venn diagram where is the region A minus B. What is A minus B? A minus B means the elements present in A but not in B. You observe this is the zone which elements present in A but not in B. Please try to understand. So you observe here this shaded region. What is this shaded region? This shaded region is A but not B. This shaded region is A but not B. So what is A minus B? All the elements present in A but not in B. Okay. Now second point, how we write A minus B in set builder form. A minus B is a set which contains an element X such that X present in A and X does not belongs to set B. X is in set A but not in B. So the set A minus B in set builder form we will write like this. Now third point in this difference of two sets, A minus B and B minus A. What you will say about these two sets? A minus B is same as B minus A. A minus B means elements present in A but not in B. B minus A means elements present in B but not in A. You observe this shaded part is A minus B. Similarly, if you observe this part, please observe here this part. This part is B minus A. Are these two are equal? No, they are different. A minus B is not equal to B minus A. You try to understand. In previous class, we learned A union B is same as B union A. A intersection B is same as B intersection A. Whereas it comes to difference between two sets, A minus B is not equal to B minus A. Now fourth point, A minus B intersection B minus A. Where is the zone B minus A? What is this shaded part? This shaded part is B minus A. This shaded part is B minus A. When it comes to their intersection, what are the elements which are common in both A minus B and B minus A? You can observe the sets A minus B and B minus A both are disjoint. There is no element common in both these A minus B and B minus A. So A minus B intersection B minus A is null set. Now fifth point, you can observe here A minus B and A. If we consider A minus B, this is A minus B. Is A minus B is subset of A? All the elements present in A minus B are present in A. We can easily understand this. You observe this is set A. This is A minus B. All the elements present in A minus B are present in A or not? Yes. So A minus B is subset of A. Similarly, what you say about B minus A? What you will say about B minus A and set B? B minus A, all the elements present in B minus A are present in B? Yes, of course. So B minus A is subset of B. Now sixth point in this difference of sets. What is A minus null set? A minus null set means all the elements present in A but not in null set. All the elements present in A minus null set is A. It can be understood very easily. Seventh point, A minus A. What is A minus A? All the elements present in A but not in A. Is it possible? All the elements present in A but not in A. What is difference between A and A? A minus A is the null set. So A minus A is null set. Symmetric difference of two sets. How the symmetric difference of two sets is defined? The symmetric difference of two sets A comma B is denoted by A delta B. You please observe here, the symmetric difference of two sets A comma B is denoted like this, A delta B. In some books, they'll denote the symmetric difference between two sets like this also. And how the symmetric difference of two sets is defined? It is defined as all the elements which are present in A are in B but not in both. Try to understand this carefully. All the elements which are present in A are present in B but not in both. We'll try to understand this by using Venn diagram. You observe here, I consider two sets A and B. What is this shaded part? You can observe here, this full, both the circles is nothing but A union B. What is this full part? This full part is A union B. But you observe the second part, that is intersection of both the sets. This is A intersection B. Please observe this area. A intersection B. From A union B, if we remove A intersection B, then we will get this shaded part. Please try to understand. A delta B is nothing but A union B. From A union B, if you remove A intersection B, all the elements present in A union B but not A intersection B. That means all the elements present in A are in B but not in both. Try to understand. Whatever the shaded part is there here, this part plus this part, this is symmetric difference between two sets. Here, symmetric difference between two sets is defined like this also. See, A minus B, we know that just now we learned this shaded region is A minus B, this shaded region is B minus A. When we do their union, then also we are getting symmetric difference of two sets. So, in this Venn diagram, the shaded part is the symmetric difference between two sets, right? Now, we'll try to understand this more clearly with an example. See, here two sets are there. Set A is 1, 2, 3, 4, 5. Set B is 1, 3, 5, 7, 9. A delta B is defined as A minus B union B minus A. Okay. A minus B, all the elements present in A but not in B. 2 is present in A but not in B. 4 is present in A but not in B. So, what you will get this A minus B? A minus B is the set 2, 4. Union, what about B minus A? All the elements present in B but not in A. You see here, 7 is present in B but not in A. 9 is present in B but not in A. So here you will get 7, 9. So when you do their union, what you will get? You will get 2, 4, 7, 9. Complement of a set. What is the definition of complement of a set? Complement of a set A is denoted by A dash or A power C, A bar. Generally, complement of set A is denoted by A dash. And how it is defined as all the elements present in universal set U but not in A. All the elements present in universal set but not in A. Try to understand. A dash is all the elements present in universal set but not in A. We will try to understand what is A dash by using Venn diagram. You observe this Venn diagram. This is set A. Which zone is known as A dash? You observe this lines part is there na, like this. This lines part is there na. This part is nothing but A dash. You try to understand all the elements present in universal set but not in A. So, A dash is all the elements present in universal set but not in A. So, A dash is U minus A. Now, we'll try to understand few important points related to complement of a set. You see this A dash means not A. A dash whole dash. A dash whole dash is nothing but A. It can be understood easily. A dash whole dash equal to A. Complement of universal set. Complement of universal set is defined as empty set. Complement of empty set. Complement of empty set is defined as universal set. Now see the fifth point. A union A dash. When we do A union A dash, what you will get? You observe here. This is set A and this part is A dash. When we do their union, what you are getting? You are getting universal set. You can understand this easily. This is set A. This circle is set A. And this horizontal, this lines part is there, na? That is A dash. If we do their union, we will get this total box. This total box is nothing but universal set. So A union A dash is universal set. A intersection A dash. You observe that A and A dash both are disjoint. There is no element common in A and A dash. So A intersection A dash is null set. Now De Morgan's law. A union B whole complement. A union B whole complement is A complement intersection B complement. Similarly, A intersection B whole complement can be written as A complement union B complement. These are known as De Morgan's law. I'll try to prove this De Morgan's law by using Venn diagram. You observe here, this rectangular box is the universal set and this is set A and this is set B. If you observe this Venn diagram, in this total 4 parts are there. You observe only A is part 1, intersection of A and B is part 2, only B is part 3. Other than these circles, whatever the remaining place is there, that is fourth part. Please try to understand what is fourth part. Other than these circles, this whole thing is fourth part. Now you see, I will try to prove this first result. A union B whole dash. What is meant by A union B whole dash? Here you try to understand A dash means not A. So A union B whole dash means which part you will get. You try to understand A union B whole dash. A union B whole dash means not A union B. Not A union B means which part will come? Which part will come, you please tell? Fourth part is not A union B. Okay. Now A dash. A dash. What is A dash? A dash means not A. Other than A, what parts are present in this? 3 and 4. So what is A dash? A dash is 3 and 4. B dash. What is B dash? B dash. B dash means not B. Not B. That means 1, 4. You try to understand this. 1, 4. Here, what is A dash intersection B dash? A dash intersection B dash is the common part present in A dash and B dash. What is the common part present in A dash as well as B dash? That is fourth part. So you can easily understand here A union B whole dash is nothing but A dash intersection B dash. Similarly, we can observe that A intersection B whole dash is nothing but A dash union B dash. And last point, what is A dash? A dash is nothing but not A. In general words, you can remember it. A dash is nothing but not A. In this class, we will learn the properties between the sets, relation between the sets. This class is very important. We use these results very frequently in the coming classes. First, you try to understand this diagram. You observe in this, total 2 sets are there. This is set A, set B. And this rectangular box is considered as universal set. You observe here part 1. What is part 1? What about set A? What is set A? Set A is this part 1 plus part 2. Please try to understand. This is set A. What is set A? Part 1 plus part 2. What is set B? Set B is part 2 plus part 3. Okay. What is part 1? Part 1 means A but not B. Try to understand here. This part 1 is what? A but not B, which is written as A minus B. A minus B means all the elements present in A but not in B. Simply I can write it as only A. Okay. Now second part. Second part is what? Second part is A intersection B. What it is this A intersection B? elements present in both A and B. Just to understand, I am writing like this. A intersection B means the elements present in both A and B. What is the third part? Third part is only B, correct or not? B but not A. So third part is nothing but B minus A. B minus A is what? B minus A is only B. Okay. Now fourth part, you observe other than this 1, 2, 3 in this box, other than this 1, 2, 3 parts, this remaining part is known as fourth part. That fourth part is what? It is nothing but not A union B. Please try to understand. This 1 plus 2 plus 3 is what? You see here, I'll write 1 plus 2 plus 3. All the parts together is nothing but A union B. Not A union B means in this box other than 1, 2, 3, what part is there? That part is fourth part. So what is fourth part? Fourth part is not A union B. To understand the coming properties, you need to know these things first. Okay, so we'll start our properties. First property, you see this A minus B. A minus B means only A. A minus B can be written as A intersection B dash. A intersection B dash means what? A but not B. B dash means not B. A dash means not A. Try to understand. A and not B. A and not B is nothing but this part 1 only. Please try to understand what I am trying to say. A minus B can be written as A intersection B dash. Similarly, what you say about B minus A? B minus A means all the elements present in B but not in A. All the elements present in B but not in A. This can be written as B intersection A dash. What it means? B but not A. So this simply we can say it as it is nothing but only B. You observe this A minus B union B. A minus B means this part 1. Try to understand. A minus B means part 1. Union. What is set B? Here in this diagram, what is set B? Set B is part 2 plus part 3. Okay. When we do the union, what you will get? A minus B is part 1. Union. Union we are doing. Set B is 2, 3. When we do their union, what you will get? You will get 1 plus 2 plus 3. Correct or not? When we do their union, 1 plus 2 plus 3. What is 1 plus 2 plus 3? 1 plus 2 plus 3 is A union B. Please try to understand. A minus B union B is nothing but A union B. Fourth property. A minus B intersection B. A minus B. A minus B means this part 1. Okay, part 1. Set B means 2 plus 3. Okay, A minus B is part 1. Set B is 2 plus 3. What is the common present in A minus B and B? Here you try to understand this. A minus B means part 1. Set B means part 2, part 3. This is first set, this is second set. Is there any part common in both? No. So these sets are disjoint. So when we do their intersection, what you will get? You will get empty set. So A minus B union set B is A union B. A minus B intersection B is empty set. You observe this. A minus B union B minus A. A minus B means which part? A minus B means part 1 plus B minus A. B minus A means part 3. A minus B union B minus A. Part 1 plus part 3, which can be written as A union B. A union B means what? 1 plus 2 plus 3 minus second part. What is second part? Second part is A intersection B. Please try to understand. A minus B union B minus A. A minus B is part 1 in this diagram. B minus A is part 3 in this diagram. A union B means 1 plus 2 plus 3 minus second part is nothing but A intersection B. If I remove this, I will get same thing. So A union B is what? A union B is 1 plus 2 plus 3 minus A intersection B is second part. If both will get cancelled, part 1 plus part 3 only you will get. So what you came to know that A minus B union B minus A is nothing but A union B minus A intersection B. This is nothing but the symmetric difference between two sets, that is A delta B. See this n of A minus B. What is n of A minus B? Number of elements present in A minus B. See this n of A minus B, number of elements present in this A minus B. A minus B means only A. So which can be written like this: number of elements present in set A minus number of elements present in A intersection B. Please try to understand. N of A. Okay, you see here n of A minus B. A minus B means which part here actually? This is the first part, right? N of A. N of A means number of elements present in first part plus second part minus n of A intersection B. N of A intersection B is second part. If both will get cancelled, you can see both is same. So n of A minus B can be written as n of A minus n of A intersection B. See this seventh property, n of A union B. We know that n of A union B is nothing but n of A plus n of B minus n of A intersection B. So many people, they don't know why we are using this formula. I just want to do why these two are equal or not. See, A union B. A union B means what? A union B is nothing but part 1 plus part 2 plus part 3. Correct? Okay. A, number of elements present in set A. Which area is set A here? 1 plus 2. Okay. N of B, number of elements present in set B. That means 2 plus 3. This is not exact proof. Just I am trying to explain this result by using Venn diagram. Minus n of A intersection B. A intersection B means second part. So if you plus 2 minus 2 will get cancelled. You observe this left hand side part is 1 plus 2 plus 3 and right hand side part also 1 plus 2 plus 3. So we can understand that n of A union B is nothing but n of A plus n of B minus n of A intersection B. You observe here, if A comma B are disjoint, when we say two sets are disjoint, if their intersection is null set, then we say that they are disjoint. So if you want to show this in Venn diagram, disjoint set means there is no common element in set A and set B. The sets will be like this. They won't be intersect, because if the sets are disjoint, their intersection is null set. There is no element common in A and B. See, if A comma B are disjoint, the sets will be like this. If A and B are disjoint, then what is the formula for n of A union B? We can write the formula like this: n of A plus n of B. Actually, n of A union B formula, n of A plus n of B minus n of A intersection B. As the sets are disjoint, A intersection B is null set. A intersection B is null set means 0 elements present in that set. So minus 0 I need to write. Instead of that, simply I'll write, if A comma B are disjoint, then n of A union B is n of A plus n of B. You observe this 19th synopsis, we learned the relation between the sets. By using Venn diagram, we can easily understand all these things. If you observe all these things, I consider for two sets A, B. Now, in 20th synopsis, we will learn the relation between the sets when three sets are given. 20th synopsis, if A comma B comma C are any three sets, then the relation between these sets. Please see this result, A minus B intersection C. See here intersection is there. A minus B intersection C is same as A minus B union. Please observe here union is there. A minus B union A minus C. This is the result you need to remember. I will try to explain this result by using this Venn diagram. You see here what is A. You observe this diagram. This is A, okay, and this is B. This is set C. What is A? Which part is A here? The A part is 1, 4, 5, 7. That is A. It can be understood easily. What is A? 1, 4, 5, 7. This part is set A. Okay. What is B intersection C? B intersection C. This is set B. This is C. What is B intersection C? B intersection C is 7, 6. Correct? So, A minus B intersection B means what? A minus B intersection C. What it mean? All the elements present in A but not in B intersection C. Correct? You observe this, 7 is there in A, 7 is there in B intersection C also. So we won't consider. What we will consider? We will consider the elements present in A only but not in B intersection C. So what you will get here, this is the zone 1, 4, 1, 4, 5. So here you observe 1, 4, 5. What is this part 1, 4, 5? 1, 4, 5 is A but not B intersection C. A minus B intersection C is the region 1, 4, 5. Now you observe here A minus B. Where is A minus B? A minus B means the elements present in A but not in B. Elements present in A but not in B. You observe here 1, 5. You observe 1, 5. 1, 5 present in A. They are not present in B. So A minus B zone is what here? A minus B is 1, 5. Okay. What about A minus C? A minus C means all the elements present in A but not in C. You observe here. This is C. What is A minus C? A minus C is 1, 4. Correct? Okay. Now you do the union of these two things. So what about union of these things? 1, okay. And all the things will come. We won't write 1 again. 1, 4, 5. You can observe here. This zone is 1, 4, 5 in this diagram. And this zone is also 1, 4, 5. So from this we can easily understand that A minus B intersection C is same as A minus B union A minus C. You observe the second result, A minus B union C. Here intersection is there, here union is there. A minus B union C is A minus B intersection. Here union is there, na? It changes to intersection. A minus B intersection A minus. So you need to remember these results. We use these results while solving the problems. A intersection B delta C is A intersection B delta. Delta means here symmetric difference between the sets. A intersection N of A union B union C. What is the formula for N of A union B union C? That is N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C. I'll try to check this result by using this Venn diagram. So what is N of A union B union C? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, right? Other than this 8. So up to 7. Okay. N of A. N of A. What is A here? A is 1 plus 4 plus 5 plus 7. Okay. N of B. What is B here? B. B is 4 plus 2 plus, you observe here, 4 plus 2 plus 7 plus 6 plus N of C. What is C? This is C. What is C here? 5 plus 7 plus 6 plus 3 minus of A intersection B. You see, what is A intersection B? This zone 4, 7. What is that? That is A intersection B. 4 plus 7 minus B intersection C. B intersection C is what? 7 plus 6 minus C intersection A. C, this is set C, this is A. C intersection A is 5 plus 7. You can understand this easily from Venn diagram. Plus A intersection B intersection C. See, this 7 is there, na? That is the zone of A intersection B intersection C. Okay. Now you see here minus 4, here plus 4, here minus 7, here plus 7 will get cancelled. Here minus 7, here plus 7 will get cancelled. Here minus 6, here plus 6 will get cancelled. When we multiply with minus, here minus 5 plus 5 will get cancelled. Minus 7 plus 7 will get cancelled. What is remaining here? So you observe here, left hand side part is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Right hand side part is also 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So I am trying to explain this result with the help of Venn diagram. Number of elements in A delta B. How many elements will present in symmetric difference between two sets? So I'll try to prove this result. We know that A delta B. What is the formula for A delta B? A delta B can be written as A minus B union B minus A. Correct? As these two sets are equal, number of elements in A delta B is same as number of elements in A minus B union B minus A. Okay. You observe A minus B, B minus A. A minus B means 1, 5. B minus A means 2, 6. They are disjoint. There is no common region for A minus B and B minus A. We already discussed earlier, A minus B and B minus A are disjoint. We know this formula, just recently we learned n of A union B formula is n of A plus n of B if A and B are disjoint. So here what it can be written as? It can be written as n of A minus B plus n of B minus A. Okay, we can write like this. N of A minus B is nothing but n of A minus n of A intersection B plus n of B minus A is what? N of B minus n of A intersection B. Okay, so if we simplify this further, what you will get? N of A delta B, symmetric difference between sets, equal to n of A plus n of B. Here minus n of A intersection B minus n of A intersection B, that is 2 into n of A intersection B. So how many elements present in A delta B means you need to remember this formula. We use this result, number of elements present in A dash union B dash. Recently we learned that A intersection B whole dash, right? A intersection B whole dash means not A intersection B, not A intersection B. What is the formula for this? It is n of universal set minus n of A intersection B. It can be understood easily. So n of A dash union B dash formula, n of U minus n of A intersection B. So with this the synopsis part is completed. In next class onwards we will start doing objective problems. Okay, let's see the first question. Which of the following is not a well-defined collection of objects? You try to understand what they are saying. Not well-defined collection. You observe here this first option. What they given? Set of natural numbers. Natural numbers are well-defined or not? Yes, natural numbers are well-defined. What are natural numbers? Everybody will say natural numbers means 1, 2, 3, 4, 5, 6 only. No one will say minus 1, minus 2, minus 3. We know that what are natural numbers. So natural numbers are well defined, but what they are asking, which of the following is not a well defined? You see vowels in English alphabet. Vowels in English alphabet well defined or not? What are vowels in English alphabet? Everybody knows vowels in English alphabet or not? A, E, I, O, U. So vowels in English alphabet also well defined, but what they are asking, not a well defined collection of objects. Good maths teacher. Collection of good maths teachers. A particular student can say that a maths teacher is good. The same teacher may not be good to your friend. So good maths teacher is not well defined. Good teacher is not well defined. Why good teacher is not well defined? From person to person the opinion may change. A particular person may feel that a teacher is good, the other person may not feel that same teacher is good. So good teacher is not well defined. So which of the following is not well defined collection of objects? Collection of good maths teachers is not a well defined collection. See the second one, collection of beautiful girls is a null set, finite set, infinite set, not a set. These are the options given. Beautiful girl. First thing, beautiful girl is well defined or not? You take a girl, a particular girl may be beautiful to you. The same girl may not be beautiful to your friend. It is not a set. Why it is not a set? Because beautiful girl is not well defined. See this third question. Collection of intelligent students in a class. Intelligent student. In what way you decide a student is intelligent student? A student who scores well, that student is intelligent student. A student who won't get good marks but he answers very quickly in class, that person is intelligent. Intelligent student is well defined or not well defined? Collection of intelligent students in a class. Intelligent student. In what sense you will decide a student is intelligent? A particular student may be good in maths subject. The same student may not be good in other subject. So intelligent student varies from teacher to teacher, person to person. So here what I am trying to say, collection of intelligent students is not a well-defined collection. Fourth question. Which of the following is empty set? You observe this first set. This is empty set. Actually, we know that empty set is denoted by phi and it will be like this. There is no element in between the brackets. But here one element is present. Is it an empty set? No, it is not an empty set. You observe this one. This is the empty set. Empty set means there is no element in between the brackets, but here one element is present. Now you see this third option. X says that x is a natural number and less than 1. You please tell a natural number which is less than 1. We know that natural number means natural number starts from 1, 2, 3, 4 like that. Okay. You see there is no natural number less than 1. So if you observe this third set, what is the third set? There is no natural number less than 1. That means if we write the roster form of this set, this is in set builder form. If I write the roster form of this set, we won't get any element in this set. It tells that this is the empty set. You observe the fourth option, set of all even prime numbers. Even prime numbers, what are even prime numbers? 2 is the only even prime number. So here the fourth option, it is a singleton set, but what they are asking, which of the following is empty set? So what is the right option? Third option. You see the fifth question, which of the following is empty set? You observe the first set, it contains x as that x is a real number and x square minus 1 equal to 0. If I solve this first option, x square minus 1 equal to 0, then x square equal to 1. If x square equal to 1, there is a chance that x is either plus 1 or minus 1. If I take x is plus 1, x square is 1 only. If I take x is minus 1, x square is 1 only. What about the first option? First option you will get like this, minus 1 plus 1. But what the question, which of the following is empty set? As per the first option contains 2 elements. This is not an empty set, it contains 2 elements. You take the second option. What is the second option? X is a real number and x square plus 1 equal to 0. So I'll solve this equation, x square plus 1 equal to 0. What is x square? X square is minus 1. What is x? X is plus or minus root over minus 1. We know that x is plus or minus root over minus 1 is nothing but I. So you got 2 values for this set. One is minus I, another one is plus I. But the point is these two are complex number. In the second option they are saying that x is a real number. X is a real number and x square plus 1 equal to 0. But here we got x as a complex number. There is no real number here. Please try to understand. So as x is a real number and x square plus 1 equal to 0. In case if they are not specified x is a real number, then we will write this. This is not an empty set. As they are specifying that x is a real number and it is satisfying this equation. There is no real number satisfying this equation. That means is as per the second option, as they specified clearly x is a real number, there is no real number satisfying this equation. So second set is the empty set. So which option is the right option? Second option is the right option. You see this third option, we will check that also. X square minus 9 equal to 0 they given, and x is equal to what? X equal to plus or minus 3. So 3 is a real number, minus 3 is a real number. So this set is not empty set. It contains 2 elements. Okay. So now sixth question. Which of the following is not empty? Try to understand here. They are specifying which of the following is not empty. We need to identify which one is not empty. Come to the first option. X is a natural number and x lies in between 1 and 2. What are the natural numbers in between 1 and 2? We know that natural numbers are 1, 2, 3, 4 like that. What natural numbers are there in between 1 and 2? There is no natural number in between 1 and 2. As per the first option, set A is empty set. But what they are asking, which of the following is not empty set? Okay, go to the second option. See here what they are saying, x square minus 2 equal to 0 and x is rational. X is rational. Rational number means you know the numbers in the form of p by q. Okay, what are irrational numbers? Irrational numbers means root 2, root 3, 2 plus root 3, 2 minus root 3, minus root 3, such type of things are irrational numbers. Okay, here the equation is x square minus 2 equal to 0. From this, what is x square? X square is 2. What is x from this? X can be taken as plus or minus root 2. When we square this, we will get 2 only. So here the point is x is root 2. Root 2 is rational or irrational? Root 2 is irrational number. Minus root 2. Minus root 2 is also irrational number. What they are specifying in this option? They are saying that x is rational and it is satisfying this condition x square minus 2 equal to 0. So what you will say about set B? it is having solution, but that solution is not rational. That solution is irrational. You observe here. So what is set B? Set B is an empty set. Now you observe the third option. X such that X is even prime number greater than, what are the prime numbers greater than 2? There is no even prime number which is greater than 2. 2 is the only even prime number, right? So what you will say about set C? Set C is empty set. What about fourth option? Fourth option, they are saying none of the above is not an empty set. Yes, first one is empty set, second one is empty set, third one is also empty set. So obviously we will choose the option none of the above. Write the solution set of the equation in roster form. Roster form, what is roster form? All the elements are listed and separated by commas within brackets. You observe these four options. All the options are in roster form only. So first what I will do, I will solve the given equation. What is the given equation? X square minus x, x square plus x minus 6 equal to 0. You just split the middle term, x square plus 3x minus 2x minus 6 equal to 0. In first two terms you take x common. What you will get? X plus 3. Here in next two terms you take 2 common. What you will get? X plus 3 equal to 0. So what it can be written as x plus 3 into x minus 2 equal to 0. So this is nothing but x equal to minus 3, x equal to 2. So what is the set you got here? If you write in roster form, roster form means all the elements are listed and separated by commas within the brackets. One value is 2, another value is minus 3. I listed all the elements separated by commas within the brackets. So this is the right option. Where is that option? See, first option, 2 comma minus 3. I written solution set of this equation in roster form. Now you see question number 8. You observe this is the set A. This set is in roster form. All the elements are listed and separated by commas within the brackets. This is infinite set. Please try to understand. Okay. Now we need to write this set A in set builder form. You observe this first option. As per the first option, what you will get as a set? First option, x is a natural number. Natural number starts from 1, 2, 3, 4 like that. Okay. Now x is n square. You take 1 square is 1. Next x is 2 square. Next x is 3 square. Next 4 square. Next 5 square. Like that we will get. So what is this? This is nothing but 1 comma 4 comma 9 comma 16 comma 25 and so on. You can observe that this first set, first option you observe, I written this in roster form, then I am getting set A only. You observe the second option. I'll just explain, but actually we came to know that first option is correct. Second option, you see what they are saying, n is a whole number. What are whole numbers? Whole numbers we know 0, 1, 2, 3, 4 and so on. When we write this in roster form, 0 square, 1 square, 2 square, 3 square, 4 square, like that you will get. You can observe this is not set A. So second option is wrong option. Similarly, third option also you will get the same thing. Integers. Integers means 0, plus or minus 1, plus or minus 2. You will get second option what answer you got. For third option, if you write the set builder form, you will get the same answer. However, we easily identified that first option is the right option. Please see question number 9. Which of the following is correct? They are asking which of the following is correct. You observe A union B. We learned this in synopsis. A union B is nothing but x belongs to A or x belongs to B. This is correct or not? Yes, first option is correct. What about second option? A intersection B. We know that A intersection B contains all the elements which present in both A and B. You observe here, and is given. Okay, second option is also correct or not? Yes, third option. A minus B. A minus B means what? A minus B means all the elements present in A but not in B. You observe here x belongs to A and x does not belongs to B given. So this third option is correct or not? Yes, correct. So you observe the fourth option, what they given? All of the above. They are asking which of the following is correct, and whatever they given first three options, they are all correct. So which option we will choose? All of the above are correct. Okay. Now you see this 10th question. Set A is given, set B is given. They are asking to find A minus B. You observe here, first you identify the elements which are common in both. Here 2 is there and here also 2 is present. And in this set 4 is there and here also 4 is there. In this set 6 is there, in this set also 6 is there. So A minus B means what you know? All the elements present in A but not in B. Whatever the elements I strike off, they are present in A, they are present in B also. So what elements you should write? All the elements present in A but not in B. So what elements remaining here? 1 is present in A but 1 is not in B. 3 is present in A but 3 is not in B. 5 is present in A but 5 is not in B. So what is the correct option? Set 1, 3, 5. Set A is given as 1, 2, 3, 4. Set B is given 2, 3, 4, 5, 6 and they are asking to find A delta B. A delta B. In synopsis, we learn the formula for A delta B. What is the formula for A delta B? The formula for A delta B is A minus B union B minus A. A delta B we can write like this also. A delta B is A union B minus A intersection B. Here in this problem I am using this formula A minus B. How to calculate A minus B? Very simple. First you identify the common elements in A and B. See here 2 is present in A, 2 is present in B. 3 is present in A, 3 is present in B. 4 is present in A, 4 is present in B. A minus B means all the elements present in A. Try to understand. All the elements present in A but not in B. Here these elements present in A as well as present in B also. So you should write only the elements in A but not in B. So what is A minus B? A minus B is set 1 union B minus A. B minus A means what? All the elements present in B. All the elements present in B but not in A. You observe these elements present in B, these elements present in A also. But actually what is B minus A? All the elements present in B only but not in A. That means what you should write? Remaining elements in set B, that is 5, 6. I hope you are understanding. When you do this union, what you will get? 1, 5, 6. You observe which option is correct here? Third option is correct. So you should remember the formula here, A delta B. What is the formula for A delta B? A minus B union B minus A. Okay. Now next question, 12th question. Universal set 1, 2, 3, 4, 5, 6 is given. And set A is given as 2, 3. And set B is given as 3, 4, 5. Then A dash intersection B dash we need to calculate. A dash intersection B dash. We can do this problem in two methods. First one, directly I'll calculate A dash. Next I'll calculate B dash. I'll do their intersection. Or else in synopsis we learn this formula. What is that formula? A dash intersection B dash can be written as A union B whole dash. A union B whole dash. What is the formula for A dash? The formula for A dash is U minus A. The formula for A union B whole dash is universal set minus A union B. So this problem can be done in two ways. I felt that doing this problem directly is easy. So I do this problem directly. So first I'll calculate A dash. What is the formula for A dash? The formula for A dash is U minus A. What I'll do now, I'll identify the common elements in U and A. See, in this set A, 2, 3 is there. In this U also 2, 3 is there. So what is U minus A? All the elements present in U but not in A. So what you will get here? You will get 1, 4, 5, 6. All the elements present in universal set but not in A. Okay. Intersection B dash 3, 4, 5 is there. Here 3, 4, 5 is there. B dash formula is what? U minus B. All the elements present in universal set but not in B. So what you will get here? Intersection 1, 2, 6. I hope you are understand. Now A dash intersection B dash. Intersection means the elements which are common in both. One is present in A dash, one is present in B dash. And 6 is present in A dash, 6 is present in B dash. So common elements only we will write. Intersection here. Intersection means the elements which are common in A dash and B dash. So what you will get here? 1, 6. So which option is the right option? Second option is the right option. I hope you are understanding. You see question number 13. They given that number of elements in set A is 28, n of B is 32, n of A union B is 50. N of A intersection B is what they are asking. Here it is simple one. This is very familiar formula. What is the formula for n of A union B? The formula for n of A union B is n of A plus n of B minus n of A intersection B. I'll substitute what values they given here. What values they given? N of A union B is 50. N of A is 28. N of B is given as 32 minus n of A intersection B. That's what we need to calculate. So I written n of A intersection B as this. You take n of A intersection B to the left hand side and you take this 50 to the right hand side. Then what you will get? N of A union B is equal to 28 plus 32 is 60, and take this 50 to this side, it will become minus 50. 60 minus 50 is what? 60 minus 50 is 10. So which option is the right option? Fourth option is the right option. Now you see the 14th question. Number of elements in set A is 50. Number of elements in set B is 20. Number of elements in A intersection B is 10. Then they are asking number of elements in A delta B. Try to understand. Number of elements in A delta B. In synopsis, I explained this very clearly. The formula of n of A delta B. I did the proof in the synopsis. Please check the synopsis once. So in synopsis, we done this. What is n of A delta B formula? N of A delta B formula is n of A plus n of B minus 2 into n of A intersection B. This is the formula we learned in synopsis. I did the proof over there. Please check that synopsis. N of A. N of A is 50 plus n of B. N of B is 20 minus 2 into n of A intersection B. N of A intersection B is 10. So here 50 plus 20 is 70. 2 into 10 is 20. 70 minus 20 is 50. So what is the right option? 50 is the right option. To do this problem, you need to remember this formula. N of A delta B is n of A plus n of B minus 2 times of n of A intersection B. You observe this question, 15th question. If set A has m elements, then number of subsets of A. In synopsis, I did this with an example. If set A has m elements, then number of subsets of A. How many subsets will be there for set A? 2 power m subsets will be there. The number of subsets of A is 2 power m. This is the formula. 16th question you see. If set A has 3 elements, number of subsets of A. As we know, if set A has m elements, number of subsets of A is 2 power m. Here the answer is 2 cube. 2 cube means 2 into 2 into 2. That is what? 8. So if set A has 3 elements, number of subsets of A is 8. If set A has m elements, then number of elements in P of A. Here you need to remember this point. If set A has m elements, then number of subsets of A is same as number of elements in P of A. Because what is P of A? P of A means power set of A, the set of all subsets of A. What I am trying to say, if set A has m elements, number of subsets of A is same as number of elements in P of A. Here number of elements in P of A is they are asking. That means 2 power m elements will be there. So what will be the right option here? Try to understand. If set A has m elements, number of subsets of A is 2 power m. If set A has m elements, then number of elements in power set, that is also 2 power m. You observe this. 18th question. If set A has 4 elements, then number of elements in P of A. What is the formula? As per this synopsis, number of elements in P of A is 2 power 4. 2 power 4 is nothing but 16. What is the right option? Third option is the right option. Okay. You observe here, 19th question. When A is subset of B, what is A union B? You observe the 20th question, what they given. When A is subset of B, what is A intersection? Here, A is subset of B means which is the bigger set. B is the bigger set because all the elements present in A are present in B. Try to understand. So, when A is subset of B, B is the bigger set. When we do union, you will get bigger set. When we do intersection, you will get the smaller set. When A is subset of B, which is the bigger set here? B is the bigger set. So you will get bigger set B. This you can understand easily with an example, but this is the direct formula. You should remember. You see this 20th question. A is subset of B. When A is subset of B, what they are asking? A intersection B. When we do their intersection, we will get the smaller set. When A is subset of B, which one is the smaller set here? Here A is the smaller. Here B is the bigger. Try to understand. A is the smaller set, B is the bigger set. When we do their intersection, we will get the smaller set only. What is the smaller set? Smaller set is A. You please see question number 21. In a class of 35 students. In a class, how many students are there? 35 students are there. Here, they given that 24 like to play cricket. 16 like to play football. Each student likes to play at least one of the two games. This is important information. That's why I changed the color of this statement. See, each student likes to play at least one of two games. How many students like to play both cricket and football? I hope you understand the question. So what I'll do, I'll start writing all the information. 24 like to play cricket. As this is JEE main, no need to write all the steps. I directly write N of C. Number of students who likes to play cricket is N of C. N of C is given as 24. How many people like to play football? N of F. N of F is 16. And you see here, this is the important statement. Once you understand this statement, this question is nothing to you. What is that question? Each student like to play at least. At least, whenever you see at least, I'll tell you what to do. Each student likes to play at least one of two games. That means in a class 35 students are there. In those 35 students, each students like to play at least one of two games. There is no student, the student who won't play any game. Each student like to play at least one of two games. Whenever you see at least, it is union. Or else we can understand here easily. Each student likes to play at least. At least means the person play cricket or football or both. Okay. So what you need to understand here, N of C union F. N of C union F is 35. This is the point you need to understand. In the question, they not mention directly that N of C union F is 35. After reading the question, you need to understand N of C union F is 35. Once you understand this, rest of all are very easy. Okay, right. Now, you see this, what they are asking. How many students like to play both cricket and football? How many students like to play both? That means C intersection F. We need to calculate. See, we learned this formula in synopsis. N of C union F. What is N of C union F? That is N of C plus N of F minus N of C intersection F. This is the formula we learned. Now I'll substitute all the information. N of C union F is what? That is 35. N of C is what? 24 plus N of F is what? 16 minus N of C intersection F. That is what we need to calculate. What I'll do, I'll take N of C intersection F to this left hand side. N of C intersection F. 24 plus 16 is 40. Now you take this 35 to this right hand side, it will become minus 35. 40 minus 35 is 5. So N of C intersection F is 5. So the number of students like to play both cricket and football is 5. So which option is the right option? Third option is the right option. Remember, only understanding the question takes time. So you don't show any hurry to do the solution first. Take your time to understand the question. Question number 22. In a group of 70 people, it is important. In a group, how many people are there? 70 people are there. 37 like coffee. 52 like tea. And each person like at least one of two drinks. What they are asking? The number of person liking both coffee and tea. So first what I will write, number of people like coffee I will write. What is N of C? The number of people who like coffee. What they given? They given it as 37. Okay. The number of people who like tea also given. N of T. N of T is they given as 52. Okay. And here this is important information. Once you understand this information, this question is nothing to you. Each person Each person means what? In this group 70 people are there, na? In that 70 people, each person like at least one of two drinks. In this group, each person like at least one of two drinks. That means there is no person who don't drink neither coffee nor tea. So here you observe once again, at least is there. At least one of two drinks. Whenever you see this, you need to understand C union T is given. What is C union T? In this group, each person, that means how many people are there in this group? 70 people are there. So this is the important information you need to understand. Once you understand this, rest of all are very easy. Okay. Then what they are asking, the number of person liking both coffee and tea. So N of C intersection T we need to calculate. Okay. And this is very familiar formula. We know N of C union T formula. What is the formula? The formula is N of C plus N of T minus N of C intersection T. Okay. N of C union T is given as 70. N of C is given as 37. N of T is given as 52 minus. We need to calculate N of C intersection T. You take N of C intersection T to the left hand side. N of C intersection T equal to 37 plus 52, 89 minus. You take this 70 to this side. This plus 70 will become minus 70. 89 minus 70 is 19. So N of C intersection T is 19. So what is the right option? Third option is the right option. Now see question number 23. Once again I am repeating. You spend some time to understand the question properly. Once you understand the question, rest of all the part is very easy. You see here, in a committee, 50 people speak French. So I directly write, the number of people who like to speak French is 50. N of F is 50. And 20 speak Spanish. N of S, the number of people who like to speak Spanish is N of S. This information is also given. N of S is 20. They speak both Spanish and French. So F intersection S is 10. Okay. So what they are asking here, the number of persons speaking at least one of these two games. Try to understand once again. Here again, at least you can say at least one of these two languages. From the last three questions you need to understand. I collected all problems of same type so that whenever you see next time you can do it very easily. Here what to calculate? The number of persons speaking at least one of these two languages means you need to understand, we need to calculate F union S. We know this formula, N of F union S. What is the formula for this? N of F plus N of S minus N of F intersection S. Okay, we need to calculate N of F union S. N of F is what? N of F is 50 plus N of S is what? N of S is 20 minus N of F intersection S is 10. Okay, 50 plus 20 is 70. 70 minus 10 is 60. So the number of persons speaking at least one of these two languages is 60. So which option is the right option? First option is the right option. Okay, you see question number 24. This question is different and little difficult compared to earlier problems. First we will try to understand what is the given information and what is to be calculated. In a class of 100 students, if 100 students are present, 55 students have passed in mathematics, 67 students have passed in physics. What they are asking? The number of students who have passed in physics only. Okay, right. So here first I'll write the given information. The number of students who passed in mathematics, 55 students passed in mathematics. This information they given. N of P. What is N of P? The number of students who passed in physics. They given it as 67. Okay. This particular point you need to understand. This information is not given. If you understand this point, it is very easy. What is that point? In a class of 100 students, they are saying that in a class of 100 students, 55 students have passed mathematics, 67 students have passed in physics. What it tells? It tells that in that class, all the students attempted mathematics and physics only na. Try to understand this please. In a class of 100 students, 55 students have passed mathematics, 67 students have passed physics. That means what? All the students in that class already attended the exam of mathematics and physics. That means n of m union p. This you need to understand. N of m union p is 100. This information not given directly in the question, that you need to understand after reading the question. Please think of it. What they are asking at the end, number of students who have passed physics only. See here, already they given number of students who passed physics. Who passed physics is different, who passed physics only different. So what they are asking, number of students who passed physics only. We need to calculate. See here, n of m is there, n of p is there, n of m union p is there. So what I'll do, first I'll calculate n of m intersection p. First I'll calculate this. Next I'll calculate n of p only. Okay. So we know this formula, n of m union p. What is the formula for n of m union p? N of m plus n of p minus n of m intersection p. N of m union p already given in the question, that is 100. N of m given in the question 55. N of p is 67. I want to calculate n of m intersection p first. You take n of m intersection p to the left hand side. So n of m intersection p is equal to 55 plus 67, 122 minus, you take this 100 to the right hand side. So this plus 100 will become minus 100. So 122 minus 100 is 22. What is this 22? Number of students who passed in both physics and mathematics. Okay, what they are asking here? They are asking to calculate the number of students who passed physics only. To understand this, Venn diagram plays very important role here. You observe here, I had drawn a Venn diagram. In this part, what is this zone? You observe, what is this zone? This zone is M intersection P. We got that M intersection P is 22, right? This zone is 22. And what about physics? The number of students who passed physics, this whole part physics is given as 67. N of P is given as 67. Please try to understand. So this full circle is 67. In this full circle, this intersection part is 22. So physics only means which part? You observe this red color part. What is this red color part? That red color part is the number of students who passed physics only. What is this green color part? The number of students who passed in mathematics and physics both. So we want this red color. How we will get? We know that this full circle is 67. They given that information. This full circle is 67. From this 67, if I remove this 22, I will get this part only now. So the number of students who passed physics only. How you will get? You will get this full, that is 67 minus this intersection part. 67 minus 22. What you will get? 67 minus 22 is 45. So the number of students who passed physics only is 45. So which option is the right option? Fourth option is the right option. Okay, last question. In a survey of 400 students, in a school, hundreds were listed as taking apple juice. Very nice. 150 taking orange juice. Good. 75 people taking both the juices. That means they are taking both apple juice as well as orange juice. Then how many students were taking neither apple juice nor orange juice? First, I'll write the given information. Number of students who takes apple juice, 100. What is N of A? Number of students who are taking apple juice. And number of students who are taking orange juice, I'll take it as N of O, orange juice. 150 students are taking orange juice. Good. 75 students are taking both N of A intersection O. They given as 75. Now what they are asking, how many students were taking neither apple juice nor orange juice? That means in this 400 students, how many students are not taking apple juice, not taking orange juice? I think they don't like the juices. Okay, so how many students were taking neither apple juice nor orange juice? We can do this problem very easily with the help of Venn diagram. You observe here total how many students are there in this survey? 400 students are there. This rectangle box contains 400 students. Please try to understand this. Okay. Now what they are saying, the number of students who are taking apple juice is 100, who are taking orange juice is 150, who are taking both. In this Venn diagram, where is the area both? See, this zone is both. So what they given? They are given this is 75. As they given number of students who take apple juice is 100, this full circle is 100. This full circle is 100. In this part is 75 means this part will be 25 only. Please try to understand. So now it comes to orange juice. The number of students who are taking orange juice given as 150. As both 75 is there, this full circle is 150. In this part is 75. So this part is what? This part is 75. I hope you are understanding. How many students were taking neither apple juice nor orange juice? That means you observe the shaded part in this box. Other than these two circles, whatever this shaded part is there, those students neither taking apple juice nor orange juice. You please try to understand. That means this full box, including the circles, this full box is 400. But other than these circles, whatever the remaining part is there, that is the part that neither taking apple nor orange juice. So how you will get this part? As we know, this full part is 400. From this 400, I'll remove this. What is this? 25 plus 75 plus 75. Okay. So 400 minus 75 plus 75, 150. 150 plus 25 is 175. 400 minus 175 is 225. You need to understand what is this 225, the number of students who are taking neither apple juice nor orange juice. So which option is the right option? Third option is the right option. You please see question number 26. A intersection A union B whole complement equal to what they are asking. We know this formula A union B whole complement. What is the formula for A union B whole complement? In synopsis we learn this formula. It is A complement intersection B complement. So here this is A intersection. A union B whole complement formula is A complement intersection B complement. You see here also intersection is there. Here also intersection is there. We know that in sets associative law holds good. So this can be written as A intersection A dash intersection B dash. Okay. A intersection A dash. What is A intersection A dash? A means we know it is set A. A dash means generally we say not A. Try to understand. A dash means not A. All the elements present in universal set but not in A. What are the common elements in A and not A? Just think it. What are the common elements in A and not A? There is no element common in A and A dash. And however, in synopsis we learned that A intersection A dash is null set. So here A intersection A dash is null set. Null set intersection B dash. See, whenever we do intersection, we will check for smallest set. See, in these two sets, which set is the smallest set? Obviously, null set is the smallest set. So, null set intersection any set is null set only. Okay. So, here null set intersection B dash is what? It is null set only. So, what will be the right option? Third option is the right option for this. See this question number 27. A minus B union B minus A union A intersection B equal to what? This can be understood easily with the help of Venn diagram. You observe this Venn diagram. Set A, set B is there. So here A minus B. Where is the part A minus B in this diagram? See, this part is A minus B. So this part is A minus B. Where is the part B minus A? See, this part. Only B. We learned this in synopsis. What is B minus A? This part, this full part is B minus A. Where is the part A intersection B? You see this part. What is this part? This part is A intersection B. When we do union of all these three parts, what you will get? You will get part 1 plus part 2 plus part 3. In synopsis we learn what is this full thing. This full thing is nothing but A union B. Correct or not? So what is the right option for this question? Right option is A union B. You see this question number 28. Set A equal to 1, set 2, 5, 3. Then the number of subsets of A. Here this question is very easy, but students will confuse with the elements. Set A contains how many elements? 3 elements or 4 elements? Please answer. Set A contains how many elements? Set A contains 3 elements. Correct or not? This is one element. The second element is set 2, 5. This is one element in set A. And the third element is 3. How many elements are there in this set A? 3 elements are there. We learned the formula. If set A is having m elements, then number of subsets formula, number of subsets, the formula is 2 power m. So here, how 2 power, how many elements are there in set A? Set A contains 3 elements. So 2 cube is 8. So how many subsets will be there for set A? 8 subsets will be there for set A. You see this question number 29. Set A contains how many elements here? Yes, answer. Set A contains 2 elements. No need to confuse in that. What are those 2 elements? First element is empty set. Second element is the set which contains empty set. Try to understand. How many elements are there in set A? 2 elements are there in set A. Then what they are asking? They are asking P of A, power set of A. What is meant by power set of A? The set of all subsets of A. The set of all subsets of A. Here, when set A contains 2 elements, how many elements will be there in P of A? 2 square elements. That means 4 elements will be there in P of A. This we already discussed in earlier problems from 1 to 25. Okay. So here P of A contains 4 elements. It is easy to identify in the options which options contains 4 elements. That is P of A. Correct or not? So here this is the option which contains 4 elements. However, if you want to write a solution in detail, what is P of A? P of A is the set of, first I written the set of all subsets of A. Now I'll write all the subsets of A. We know that empty set is subset of every set. So first I'll write that. And we know that every set is subset to itself. So I'll write that. Okay. Next, singleton elements. See here, what is the singleton element? This is one subset of A. This is subset of A or not? Yes. And I'll write one more, that is like this. Or else directly by seeing the options you can decide. If set A contains 2 elements, P of A contains 4 elements. So from that directly we can choose this option. You see question number 30. Set A is empty set. Then P of A. P of A. A is empty set means how many elements will be there in set A? As A is empty set, number of elements in set A is 0. How many elements will be there in power set of A? How many elements will be there? 2 power 0. 2 power 0 means 1 element. So P of A contains 1 element. What is P of A actually? P of A is the set of, please try to understand, the set of all subsets of A. All subsets of A. We know that empty set is subset of every set. Empty set is subset of every set. So you observe here, this is the only subset we are getting for set A, and we know that P of A contains only 1 element. So what will be the right option here? Third option is the right option. Okay. So this question number 31. Universal set is given from 1 to 10. Set A is given as a 1, 3, 5, 7, 9. Then they are asking to calculate A dash. It is simple only. What is the formula for A dash? The formula for A dash is universal set minus A. First you identify the common elements. One is 3, 5, 7, 9. These are the common elements in universal set as well as in A. We know that A dash means all the elements present in U but not in A. So you write all the elements present in universal set 2, 4, 6, 8, 10. So these are the elements present in universal set. These elements are not in set A. So what is the right option here? First option is the right option. You see question number 32. Set A is given as open interval 2, 4. Set B is given as closed 3, open 5. Then what is A intersection B? We will try to understand this on the number line. You observe this number line. What is meant by open interval 2, 4? Open interval 2, 4 means all the real numbers in between 2, 4. And as they given open interval, 2 is not included, 4 is not included. Like this. You please try to understand, this is open interval 2, 4. All the real numbers in between 2 and 4, 2 is not included, 4 is not included because they given open interval. Now I'll write set B. Set B is what? Closed interval 3, open interval 5. It means that all the real numbers in between 3 and 5, 3 is included, 5 is not included. How we represent this on the number line? You observe this set B. This green color one is set B. 3 is included. That's why I written the dark circle. 3 is included. 5 is not included. Now you observe these two colors. These two. This is set A. This is set B. What is the common region in set A and set B? You observe this zone is the common zone. Correct? This is the common region between set A and set B. So what they are asking in the question? They are asking A intersection B. A intersection B means which is the common part in set A and set B. 3 is there in both the sets. Yes, 3 is there in both the sets. So I'll write closed interval 3. And 4 is there in both the sets. In this first set 4 is not there. In the second set 4 is there. 4 is not in common. So what we will write? Closed 3, open 4. So closed 3, open 4. This is the right option. So which is the right option here? Second option is the right option. Question number 33. If A and B are two sets such that A union B equal to A, then they are asking what is A intersection B. What they given here? They given that A union B equal to A. We know that when we do the union, we will get the bigger set. So here A union B equal to A means A is the bigger set here. A is the bigger set means what I am trying to say, B is subset of A. If B is subset of A is the bigger set, B is the smaller set. So as they given A union B equal to A, they are trying to tell you that B is subset of A. Okay. When B is subset of A, what is the bigger set here? A is the bigger set, B is the smaller set. Remember, when we do union, we will get the bigger set. When we do the intersection, we will get the smaller set. Here, A intersection B. So, in this A and B, B is subset of A. That means here B is the smallest set. So, when we do their intersection, we will get set B. This point we already discussed clearly in the synopsis. Okay. So A intersection B is what? Set B. So what is the right option? Second option is the right option. See this 34th question. X says that X is a letter in the word mathematics. Then N of A. You observe here this set is in which form? Roster form or set builder form? This given set is in set builder form because all the elements are represented with its single common property. What I'll do, I'll write this set in roster form and then I'll find out how many elements are there in set A. So I'll write the given set in roster form. Letters, first letter M, A, T, H, E. You observe here M is repeated. In roster form, we won't write repeated numbers or repeated letters. As M is already written, we won't write it again. Next A is also written again. Next T also written. I, okay. C, yes. So these are the letters of the word mathematics. We will get like this when we written this set in roster form. Okay. So now you observe how many elements are there in set A. 1, 2, 3, 4, 5, 6, 7, 8. So number of elements in set A is 8. So what is the right option here? Fourth option is the right option. The smallest set such that A union the set 1, 2 is 1, 2, 3, 5, 9. Okay. So here we will verify through options. Try to understand. I am verifying the first option. When we do this union, you are getting 1, 2, 3, 5, 9. You observe that in the both the sets 9 is not there. So first option is wrong option. Go with the second option. What is the second option? 3, 5, 9 union 1, 2. When you do their union, you are getting the set 1, 2, 3, 5, 9. Check it. This I am doing this problem by verification method. I taken set 3, 5, 9. See the union 1, 2, 3, 5, 9. Yes, I am getting this. This is correct only. Similarly, you check this third option. 1, 2, 5, 9 union 1, 2. When we do this union, what they given here? They given 1, 2, 3, 5, 9. You check it. When we do their union, see 3 is not there in both the sets. How you will get this in the union? So this is wrong option. Oh, next, choose the fourth option. What is fourth option? 1, 2 union. What they given here? 1, 2. When we do their union, what you are getting? You are getting 1, 2, 3, 5, 9. You are getting this? No, this is absolutely wrong. So obviously right option is what? When we choose this set, the set 3, 5, 9, when we do union with this set 1, 2, then you will get this answer. You observe this question. Set A is 8 power n minus 7n minus 1, where n is a natural number. Set B is 49 into n minus 1, where n is a natural number. Then which of the following option is correct? This is a little difficult problem on set theory. To understand this problem, you must know binomial theorem. In case if you don't know that, you just know this statement from binomial theorem. What is that statement? 1 plus x whole power n is NC0 plus NC1 into x plus NC2 into x square plus NC3 into x cube plus and so on plus NCn into x power n. This is the statement we have from binomial theorem. How we use binomial theorem in this problem? You observe here 8 power n is there. 8 power n, I'll write it as 1 plus 7 whole power n. In case this type of problems, here 4 power n is there, then we will write 1 plus 3 whole power n. You observe in this expansion, in place of x, here 7 is there. In this right hand side also, in place of x, you just write 7. Then what you will get? NC0 plus NC1 into, in place of x, you just write 7 plus NC2 into, in place of x, you just write 7 plus NC3 into, in place of x, you just write 7 plus and so on plus NCn into, in place of x, you just write 7. Okay. So here left hand side 1 plus 7 is 8. It can be written as 8 power n. NC0 standard formula. NC0 is 1. 5C0 is 1. 7C0 is 1. Like that NC0 standard formula is 1 plus NC1. NC1 standard formula is n. 5C1 is 5. 3C1 is 3. 10C1 is 10. Like that NC1 is n. If you already done binomial theorem, then you can understand this very easily. Otherwise, you remember this formula NC1 is n. You will learn this in binomial theorem. It is 7 plus. Here you see in this term 7 square is there. In this term also 7 square is there. Like that here also 7 square is there. We can take a 7 square common from these remaining terms. You observe this term, this term, this term. From these terms we can take 7 square common. So I'll take 7 square common. If I take 7 square common, what I'll get? I'll get NC2 plus NC3 into, as you taken 7 square common, here 7 will be remaining, plus and so on, plus NCn into, if we take 7 square common here 7 power n minus 2 is remaining. If you want, see, you multiply this 7 square and 7 power n minus 2. What you will get? 7 square into 7 power n minus 2. As base are equal, power should be added now. 2 plus n minus 2. This is 7 power n only. Okay. This 8 power n I'll write as it is. You see this 7n, n into 7 is 7n. Take this to the left hand side, this plus 7n will become minus 7n. You take this plus 1 to this left hand side, this plus 1 will become minus 1. So 8 power n minus 7n minus 1 is 7 square. What is 7 square? 7 square is 49. You observe here, this 7 square is 49. You need to know this. In binomial theorem, you learn all these things. This term is an integer. This term is also integer. This term is also an integer. If we add all the integers, again you will get a integer. Again you will get a integer. So what you came to know? You came to know that 8 power n minus 7n minus 1. This is multiple of 49. This expression is multiple of 49. What it is saying? This is also multiple of 49. Please try to understand. Set A is multiple of 49. Set B also multiple of 49. Now when you observe the options, you will get confusion with first option and fourth option. Which option is right option? In first option, it is strictly subset of B. A is proper subset of B. In fourth option, A is proper subset of B as well as A equal to B also there. How we identify A is strictly subset of B or A is subset of B? To understand that, I am writing few steps here. I am not saying you write these steps in examination. To explain which option is correct in first option, fourth option, I am writing these things. You do not go through these things. Directly we can say the answer. First let me explain. What I will do, I will put n is a natural number in set A as well as set B. All natural numbers I am taking. All these numbers I'll keep in set A. Just to understand you, I am writing these steps. Not at all necessary to write these things in examination. If I put n equal to 1 in this, I am getting 0. If I put n equal to 2 in this, you will get 49. You can check if you want. You just put n equal to 2 in this and you just simplify, you will get 49. Put n equal to 3 in this, you will get 490. Like that, if you put n equal to 4, then you will get 4067. Like this type of numbers you are getting in set A. If I keep these natural numbers in set B, if I keep these natural numbers, what happens? I found that I am getting numbers like this: 0, 49, 98, like that, 490. If we keep on continuing, 4067, like that. I am not recommending you to do like this in examination. Just to explain which option is correct, I am writing these things. You observe here, set A contains multiple of 49, but not all multiples of 49. Set B contains multiple of 49, but it contains all the positive multiples of 49 including 0. Here you can easily understand A is just a strictly subset of B, because you see in this 98 is there in this set B, but in this 98 is not there, correct? So here A is strictly subset of B, here A is not equal to B. So we can say that A is proper subset of B. So what is the right option? First option is the right option. So fourth option is wrong option. So in this question, what is the right option? A is subset of B. We'll try to understand same type of problem with another example. You observe question number 37, which is similar to previous problem. So to do this problem, we need the knowledge of binomial theorem, especially this statement from binomial theorem. 1 plus x whole power n. What is this statement? NC0 plus NC1 into x plus NC2 into x square plus and so on plus NCn into x power n. How we use this binomial theorem to solve this problem? Here 4 power n is there, na? So this 4 power n can be written as 1 plus 3 whole power n. Now in this expansion, wherever x is there you write 3. So in this expansion, wherever you see x, there you write 3. Then what you will get? NC0 plus NC1 into 3 plus NC2 into 3 square plus and so on plus NCn into 3 power n. Okay, 1 plus 3 is what? 4. 4 power n equal to NC0 value, standard formula, that is 1. NC1 value is n into 3 plus, you observe here 3 square is there, in this term also 3 square is there, in this term also 3 square is there. So I can take 3 square common. If I take 3 square common, what I'll get? NC2 plus NC3 into, here if I take 3 square common, 3 will be remaining, plus and so on plus NCn into, if I take 3 square common, here you will get 3 power n minus 2, like earlier problem only. Now 4 power n You take this plus 3n to this left hand side, it will become minus 3n. You take plus 1 to this left hand side, it will become minus 1 equal to 3 square. 3 square is what? 9. You see, this is an integer, this term is an integer, like that this term is also an integer. So here sum of all integers is again an integer. Whatever this expression is there, that is an integer. Okay. Now you came to know that set x is a multiple of 9. You see here set y is also a multiple of 9. Now you will get the confusion with the first option as well as fourth option, as x is strictly subset of y or x is subset of y. Here strictly subset means we call it as x is a proper subset of y. So which one is correct? To understand this, I'll go with this procedure. I'm not recommending you to do all these things in examination. Just to understand this question more clearly, I am explaining this. Like that, I am getting the number. I put n equal to 1 in this, I am getting 0. If I put n equal to 2 in this, I am getting 9. Like that, I am getting x values like this. Set y, I'll keep these natural numbers in set y also. When I put n equal to 1, I am getting 0. When I put n equal to 2, I am getting 9. When I put n equal to 3, I am getting 18. Next 27. Like that, 54 and so on I am getting. X is a set which contains multiple of 9 but not all multiples of 9. Y is a set which contains all multiples of 9. That is the point you need to understand. That's why I written all these things. So here x is proper subset of y. X never be equal to y in this case. So what is the right option? X is proper subset of y is the right option. What about this fourth option? This is wrong option. I hope you understand these two questions. You see question number 38. If AN, the set AN is defined as which contains all the elements like AX where x is a natural number, then 3n intersection 7n is what they are asked. First, I'll write clearly what is 3n, what is 7n in roster form. 3n, how it will be? 3n will be like this. 3 into x. What is x here? X is a natural number. So here it will be 3 into 1. 3 into 2. Try to understand. AN is in the form of AX where x is a natural number. 3n will be in the form of 3x where x is a natural number. 3 into 2, 3 into 3, 3 into 4. Like that you will get 3 into 14. Like that so many elements will be there. It's an infinite set. So here 3 into 1 is what? 3 into 1 is 3, 3 into 2 6, 3 into 3 9, 3 into 4 12. Like that it's a 3 table. You will get 15, 18, 21. If you keep on going like this, 13 4s are 42. Like that it's an infinite set you will get. Okay, 3n looks like this. 3n is a multiple of 3. What is 7n? 7n contains an elements in the form of 7x where x is a natural number. So the set will be like this: 7 into 1, 7 into 2, 7 into 3. Like that this type of elements will be there in 7n. As all these elements are multiple of 7. If we simplify this, 7 into 1 7, 7 2s are 14, 7 3s are 21, 7 4s are 28. Like that 7 6 are 42. Like that all 7 table. It's just nothing but it's just like a 7 table. Okay, now what they are asking in the question? They are asking 3n intersection 7n. Okay, we know that intersection means the elements which are common in both 3n as well as 7n. You observe here, first element, common element is what? 21. 21 is the common element. 21 is a multiple of 3. 21 is a multiple of 7 also. Similarly 42. 42 is a multiple of 3. 42 is a multiple of 7 also. So what happening here? 21, 42. Try to understand common elements. 21, 42. Next common element, if we search for next common element, you will get 63. 21 3s are 63. So what you are getting? You are getting multiples of 21. Try to understand. These things can be written as 21 into 1, 21 into 2, 21 into 3. Such type of elements, all multiples of 21 you are getting. So what is this? It is of the form 21x. So this set is nothing but 21n. So what is the right option here? First option is the right option. I hope you are understanding. Now you see second problem also of same type. You observe the question first. The set an contains elements of the form ax, and they are saying that bn intersection cn is dn. You observe here they are asking bn intersection cn is what? Here they given bn intersection cn is dn. they already mentioned it is Dn, where B comma C are relatively prime. Relatively prime means the GCD of the elements B comma C is 1. You observe here, what is the GCD of 3 7? You know how to calculate GCD of 3 7? You just divide bigger number by smaller number. This 3 in the 7 2 times. 3 2s are 6, 7 minus 6 1. Again you divide this 3 with 1. 3 1s are 3. So the GCD will be 1. If GCD of 3 7 is 1, we say that 3 7 are relatively prime. Just now we came to know that 3n intersection 7n is 21n. 3 and 7 are relatively prime. Okay, they are asking what is Bn intersection Cn. Actually, as per this above problem, what is Bn intersection Cn? That is BCn. Correct or not? But in this, they given Bn intersection Cn is Dn. I hope you are understanding. Dn equal to BCn. So what is D here? D equal to BC. So what is the right option? First option is the right option. Question number 40. What is the given information in the question? A survey shows that in a city that 63% of the citizen like tea. 63% of citizen like tea, whereas 76% like coffee. Okay? If X% like both tea and coffee, then which of the following option is correct? From the synopsis, we know this point. N of T union C is less than or equal to 100 because we are considering in terms of percentage. So here T means, N of T means the number of people who likes tea. N of C means the number of people who like coffee. We know that N of T union C is less than or equal to 100. And we know this formula N of T union C. What is the formula for N of T union C? N of T plus N of C minus N of T intersection C is less than or equal to 100. Okay. N of T, what is they given? 63% of the citizen like T they given. So I'll write this is 63 plus N of C, 76% likes coffee. Na? So in place of N of C, I'll write 76 minus N of T intersection C. That means the people who like both tea and coffee. Here they given that X% like both tea and coffee. So I'll take this as X is less than or equal to 100. Now you take this X to the right hand side and take this 100 to the left hand side. 63 plus 76 is 139. 139, you take this 100 to the left hand side. 139 minus 100 less than or equal to. If we take this X to the right hand side, this minus X will become plus X. 139 minus 100 is 39. 39 is less than or equal to X. From the synopsis, we know this result, or from the Venn diagram, we can easily understand this. N of T intersection C is less than or equal to N of T, and N of T intersection C is less than or equal to N of C. Here, T intersection C is given as X. So, N of T intersection C, I'll write X. X less than or equal to, what is N of T? N of T is 63 and N of T intersection C is X. X less than or equal to N of C. N of C is given as 76. So your AND condition is there. That means N of T intersection C satisfies both the inequalities here. So here X less than or equal to 63 and X less than or equal to 76. So if we consider intersection of these two inequalities, common elements of these two inequalities, you will get X less than or equal to 63. Please try to understand. In this, all the elements less than 63 are present. In this also, all the elements less than 63 are present. From these two, I can write that X is less than or equal to 63. This is the second condition we got. You observe the first condition and second condition. From 1 and 2, what you can write? See here, they given from 1, we can write like this. 39 is less than or equal to X. From the second, you can write X less than or equal to 63. So 39 less than or equal to X less than or equal to 63. So what is the right option? Fourth option is the right option. I hope you understand this problem. If N of A intersection B dash is 5, comma, N of B intersection A dash means A complement here. N of B intersection A complement is 6 and N of A intersection B is 4. Then what is N of A union B? We can easily understand this with the help of Venn diagram. You observe this Venn diagram. In this, you can see three parts. See, this is first part and this is second part and this is third part. Okay, what is first part? First part is A only. You observe here A intersection B dash. A intersection B dash, it means A but not B. We know that B dash means not B. A intersection B dash means A but not B. So N of A intersection B dash is the first part. This part is what? First part is what? N of A intersection B dash, that is given as 5. This part is given as 5. You see here B intersection A dash, that means B but not A. Which part is that? This third part is there, na? This third part. The third part is B but not A. That means this is 6. And A intersection B is given as 4. A intersection B is which part? The second part is there, na? This is intersection of both A and B. This we already discussed in synopsis. Okay, this is what? This part is A intersection B. A intersection B is given as 4. What they are asking in the question? N of A union B they are asking. What is N of A union B? We know that part 1 plus part 2 plus part 3. This will give the N of A union B. Is it clear or not? So what you can write here? 5 plus 4 plus 6. So this will be 15. So what is N of A union B here? N of A union B is 15. I hope you understand. So what is the right option? Second option is the right option. You see question number 42. N of A minus B is given as 25 plus x. N of B minus A is given as 2x. And N of A intersection B is given as 2x. What they are saying, if N of A is same as 2 times of N of B, then the value of x. This problem is similar to earlier problem. We will try to do this with the help of Venn diagram. You observe this Venn diagram. In these 3 parts are there. What is this first part? First part is only A. Only A. It can also be written as A minus B or A intersection B dash. We learned these points in the synopsis. A minus B is same as A intersection B dash. So here first part is what? First part is A minus B. What is second part? Yes, what is second part? Second part is A intersection B. What is third part? Third part is B minus A. Is it clear or not? Yes. So here what the information they given? They given that N of A is 2 times of N of B. This information they given. How we can write N of A in terms of A minus B? This, observe this Venn diagram. N of A is nothing but number of elements in A minus B plus number of elements in A intersection B. Try to understand. First part plus second part is what? It is number of elements in set A or not? What about second part plus third part? That is number of elements in set B or not? This we can understand by seeing this Venn diagram. So here equal to 2 times of N of B. N of B means second part plus third part. What is second part? N of A intersection B plus third part. Third part is N of B minus A. You see here N of A minus B already given in the question. What it is? It is 25 plus x. Okay. Plus what is N of A intersection B? N of A intersection B is given as 2x equal to 2 times of N of A intersection B. N of A intersection B is given as 2x plus N of B minus A. That information also given. It is 2x. If we simplify this, then we will get the value of x. See here 25 plus x plus 2x is 3x equal to 2x plus 2x is 4x. 4x into 2 is 8x. Okay. So here 25 equal to 8x minus 3x is what? 8x minus 3x is 5x. This 5 in this 25 how many times? 5 times. Therefore, x equal to 5. Here they are asking the value of x. We got x is 5. So what is the right option? Second option is the right option. You observe this question number 43. The shaded region of the given figure. They are asking the shaded region of the given figure is what? You observe here which part is shaded here. You can see this full is A. This full first circle is A. But if you observe only this part is shaded. This is only A. Correct or not? What is this part? This part is only A. Only A. What is actual A? Actual A is this full circle. Okay. This part is only A. Now you observe the options. Which options gives the meaning only A, that is the right option. You see this fourth option, A minus B union C. What is this? A minus B union C. It means that A but not B union C. We know what is A minus B. What is A minus B? A minus B means A but not B, correct? So here A minus B union C means what? A but not B union C. What is B union C? You observe. Whatever BC is there, this is B union C. We did this type of things earlier also. This whole thing is B union C, correct? Here A but not B union C. It gives the clear meaning that it is only A but not B union C. So what is the right option here? Fourth option is the right option. Now you see question number 44. The shaded region of the given figure. You observe the shaded part. You see this part. We earlier already discussed this. What is the shaded part? Shaded part is A minus B. A minus B means what? A but not B. What about this part? Similarly, this is only B. That means B but not A. You can understand this. See, this shaded part is A minus B. This shaded part is B minus A. So this gives what option is the right option here? A intersection B, it's a wrong option. A union B means this whole thing will come including this part also, but A union B is also wrong. A minus B means only this part. Here this part is also mentioned, this is also wrong. So you see A minus B union B minus A. This is A minus B union B minus A. So what is the right option? Fourth option is the right option. I hope you are understanding. Now you see question number 45. The shaded region of the given diagram. You observe this shaded region. Full A is there, correct? Full A is there, and you can observe here B intersection C is also there. Try to understand. In this shaded part, full A is there and B intersection C is also there. You can understand this. See, B intersection C is also part of this, correct? So you observe A and B intersection C. See the second option, A union B intersection C. Union means all together will come, correct? A also will come, B intersection C also will come. So what is the shaded part? The shaded part is A union B intersection C. So what is the right option here? Second option is the right option. I hope you understand. Observe, this is the question given in Kcet 2021. This question is from sets chapter. In this, tricky part is some part of the question is given in percentages and some part of the question is given in directly. So first try to understand what is the question. In a certain town, 65% of families own cell phones. Actually, this is less number. I think around 90% of the families own cell phones now, I think. Okay. 15,000 of families own scooter. You observe this is not in percentages. Okay. And 15% of families own both. That means 15% of families having scooter as well as cell phone. Okay. Taking into consideration that the families own at least one of the two. Here they are trying to say that in that town, if we take any family which contains at least one of these two, they contains at least cell phone or scooter. Okay. Then what they are asking, the total number of families in the town is the total number of families in the town. Here if you observe the question, this numbers, by seeing these numbers we can easily say that this is not in percentages. You observe here I written that let total number of families in a town equal to X. This is not in percentage. I didn't written X percentage. Total number of families in a town is X. X number of families are there in that town. Okay. So here what they given, 65% of families own cell phones. That means here what I'll do, number of families who own cell phones, I'll consider it as N of C. Number of, here in this question, N of C means number of families who own cell phone. In the question they given 65% of the families own cell phones. Here 65% of X families is what? 65% of X families is what? It is nothing but 65 into X divided by 100. This will gives you 65% of X. Okay. And they given that 15,000 families own scooter. I'll write it as N of S. N of S means the number of families who own scooter. They given it as 15,000. and they given that 15% of families own both n of C intersection S equal to what? 15% of families own both. What is 15% of X? 15% of X is 15X divided by 100. What they are asking in the question, the total number of families in a town. Here, this is important point, taking into consideration that the families own at least one of two. It means that n of C union S is what? N of C union S is nothing but number of families in the town. We take a number of families in the town as X. That means n of C union S is what here? N of C union S is X. So actually they are asking total number of families in the town. That is nothing but n of C union S we need to calculate. I taken total number of families in the town as X na. That means I need to calculate X. So here I will write the formula n of C union S equal to n of C plus n of S minus n of C intersection S. What is n of C union S? N of C union S is X. Okay. Equal to n of C. What is n of C? That is 65X divided by 100. Okay. Plus n of S. N of S number is given directly. N of S is 15,000. So n of S is 15,000 minus n of C intersection S, that is 15X by 100. Now actually what I want to calculate from this? I want to calculate X value. So I'll simplify this to get X value. Okay. Here X equal to, you can observe here, first I'll simplify these two. You can see here 100 is there, here 100 is there. So LCM is 100. So in the numerator 65X minus 15X, that is 50X by 100. So what is this? This is 50X divided by 100 plus 15,000. You observe here 50 in this 100, it cancel 2 times. So what you will get here? Here you will get that X equal to X divided by 2 plus 15,000. Okay. Now you take X by 2 to this side. What you will get? X minus X by 2. X minus X by 2 is nothing but X by 2. So what you will get here? Left hand side X by 2 equal to 15,000. From this, what is X? X equal to 30,000. What is X? Number of families in a town is X. They are asking to calculate number of families in a town. I taken it as X. I got X value as 30,000. So what is the right option here? You can see 30,000 is the right option. So option B is the right option for this problem. I hope you understand this. You observe this is the question given in 2020 Kcet 2020. What is this question? Set A equal to 1, 2, 3, 4, 5, 6. Set A contains 6 elements. Then number of subsets of A which contains at least 2 elements. You need to write number of subsets of A which contains at least 2 elements. For example, here I'll try to explain this what they are asking. You see 1, 2, 3. This is subset of set A, correct? Because all the elements present in this set which are present in A. So this is one subset of A. This contains 3 elements. And you observe, I'll write one more subset like 1, 4. This is subset of set A because which contains all the elements present in this set are present in A. If I write like this, this is the subset of set A, but it contains only one element. But what they are asking in the question, they are asking which contains at least 2 elements. The number of subsets of A which contains at least 2 elements. This problem can be done in 2 ways. First, I'll do easy method, and second one also easy but little lengthy. Let's see both the methods. Okay. First point, what they given in the question, set contains 6 elements. Okay. When set contains 6 elements, the number of subsets of a formula is what? If set A contains 6 elements, number of subsets of a formula. Number of subsets of a formula is 2 power number of elements in set A. Correct? So that equal to 2 power. Here set A contains how many elements? 6 elements. 2 power 6 is what? 2 power 6 is 64. That means total number of subsets of set A equal to 64. Number of subsets of set A. What is the formula? 2 power n of A. N of A, number of elements in set A is what? 6. 2 power 6 is what? 64. So total for this set, we can write 64 subsets. But what they are asking, the number of subsets which contains at least 2 elements. See, for this set, what I'll do now, I'll write number of subsets which not contains at least 2 elements. For example, you see here, empty set is subset of set A or not? Yes or no? Empty set is subset of A. Yes or no? Yes. Empty set is subset of A, which contains 0 elements. Now, I'll write singleton set 1. This is subset of set A, but this set does not contains at least 2 elements. It contains only 1 element. Like that, I'll write all the sets which does not contains at least 2 elements. So what I'll get here, singleton set 1, singleton set 2, singleton set 3, singleton set 4, singleton set 5, singleton set 6, like that I'll get. If I write like this is the set which contains 2 elements. So it comes under at least 2 elements scatter. So you cannot take this one. So these are the sets which does not contains at least 2 elements, and these are all subsets of set A. I hope you understand. So here, how many subsets are there? 1, 2, 3, 4, 5, 6, 7. So total 7 subsets are there which does not contains at least 2 elements. So what they are asking in the question, look here what are written. The number of subsets of set A which does not contains at least 2 elements. How you will get this? So total number of subsets, what we got here? You observe, I got the total number of subsets is 64. From this 64, if I remove these 7 subsets, okay, then what I will get? From 64, if I remove all these 7 subsets, what I will get? I will get number of subsets which contains at least 2 elements. 64 minus 7 is what? 64 minus 7 is 57. You observe the option. Which option is right option? Option B is the right option. And we'll see now another method for this. We'll see another method to solve this problem. What is that another method? As they are asking number of subsets of A which contains at least 2 elements. How many subsets can be formed for this set which contains 2 elements? How many subsets can be formed which contains 2 elements? Here 6C2. 6C2. In permutations and combinations we will learn this notation. 6C2. 6C2 means number of subsets of set A which contains 2 elements. 6C2 will gives you number of 2 element subsets of set A. Okay, 6C2 will gives you what? Number of 2 element subsets of set A. For example, this is one subset 1 comma 5, next 1 comma 6, next 2 comma 4. These are all 2 element subsets of set A. Like that, how many 2 element subsets we will get means 6C2 plus 6C3. What is 6C3? Number of 3 element subsets of this set A. Okay, next 6C4, next 6C5, next 6C6. So if I simplify and if I add all these things, then you will get the total number of subsets of set A which contains at least 2 elements. I'll simplify these things. See here, 6C2 we need to calculate. We have shortcut to calculate 6C2. You write like this 6 by 2 and you write decreasing numbers like this. After 6, decreasing number is 5. After 2, decreasing number is 1. Once you got 1 in the denominator, you need to stop. 2 in the 6 3 times. 5 3s are 15. So what is 6C3? 6C3 is 15 plus 6C3. How to calculate 6C3? You write like this 6 by 3 into decreasing numbers. 5 by 2 into 4 by 1. Once you got 1 in the denominator, you need to stop. You look here, 3 2s are 6, these 2 will get cancelled, 5 4s are 20. So 6C3 is 20 plus 6C4. We know this formula, NCR is same as NC n minus R. Here 6C4 is same as 6C 6 minus 4. That is nothing but 6C2. So 6C4 value is same as 6C2. What is 6C2? 15. So you write 15 here plus 6C5 is same as 6C1 because NCR equal to NC n minus R. 6C1 value is 6 plus 66 value is 1. So if I add all these things, what I'll get? You see here 15 plus 15 is 30, 30 plus 20 is 50, 50 plus 7 is 57. So the total number of subsets of set A which contains at least 2 elements is 57. Here, why I did in the second method, in case if they ask the question, how many subsets of set A will be there which contains, how many 3 element subsets are there for set A? How many 3 element subsets are there for set A means 63 is the answer. How many 4 element subsets will be there for set A means 64 is the answer. I hope you are understanding. So for this problem, option B is the right option. You observe this question. This is the question given in Kcet 2019. Here, if U is the universal set with 100 elements, A and B are two sets such that n of A equal to 50, n of B equal to 60, n of A intersection B equal to 20, then n of A complement intersection B complement equal to. Here you need to know one formula to do this problem. That formula is A dash intersection B dash can be written as A union B whole dash. Right? We learned this formula in theory part related to sets. A dash intersection B dash is A union B whole dash. Here what they are asking in the question they are asking n of A dash intersection B dash. In place of A dash intersection B dash, what I can write? I can write that A union B whole dash. Okay. So here you need to know one formula. N of A dash is n of universal set minus n of A. N of A dash formula is n of U minus n of A. Here U is the universal set. So here this is one set. This is also like n of A dash only. So what is the formula for this? The formula is n of universal set minus n of A union B. Okay, n of universal set. You observe in the question they given, U is the set with 100 elements. That means number of elements in universal set is 100. So n of U they given 100 minus of n of A union B. You know the formula for n of A union B. What is the formula? N of A plus n of B minus n of A intersection B. This is the formula for n of A union B. They already given n of A, n of B, n of A intersection B. Just substitute these values in this. So what you will get? You will get 50 plus 60 minus 20. Okay. So that equal to 100 minus 50 plus 60 is 110. 110 minus 20 is 90. So 100 minus 90. 100 minus 90 equal to 10. So which option is the right option here? You can see option D is the right option. This is the question given in Kcet 2017. You observe this question. What they given? A and B are two finite sets and A is subset of B. Then which of the following are true? Here in theory part we learned about this. When A is subset of B, what are the points you know? Here we know these points. When A is subset of B, we know what is A union B and what is A intersection B. What is A union B? What is A intersection B? Here A is a subset of B means what? All the elements present in set A are present in set B. Here when A is subset of B, B is the bigger set and A is the smaller set. Right? We already discussed these points in theory. A is the smaller set and B is the bigger set. When we do union, we will get the bigger set. A union B equal to B. When we do the intersection, we will get the smaller set. Smaller set is A. In theory part, I given detailed explanation for this point. When A is subset of B, A union B is B, A intersection B equal to A. Here, you observe A union B is one set, B is also one set. They are saying that these two sets are equal. Two sets are equal means they must be equivalent. Equivalent means number of elements in both the sets must be same. So here from this what I can write? I can write that n of A union B equal to n of B. You observe this option, this given in the options, n of A union B equal to n of B is there. And from this we can know this also, n of A intersection B. N of A intersection B is what? As they given these two sets are equal, they are equivalent also. That means number of elements present in both the sets must be same. n of A intersection B equal to n of A. Both are correct options only. Here in this question they given this one, A union B, n of A union B equal to n of B. So option A is the right option. I hope you understand this. Now see this question. This is the question given in Kcet 2015. What they are asking, write the set builder form. You know what is set builder form, what is roster form. In this question, all the elements are listed and separated by commas. That means this is in roster form. This is in roster form. We need to write this in set builder form. Set builder form means what? All the elements are represented with its property. You observe here, for first option, what they given? A says that x is an integer. You know what are integers? 0, plus or minus 1, plus or minus 2, plus or minus 3, like that you will get. But in this set only minus 1 plus 1 are there. So first option is the wrong option. Now see the second option. X is a root of this equation, x square plus 1 equal to 0. I'll write here, in case x square plus 1 equal to 0, what is x square? X square equal to minus 1. What is x from this? X can be written like this, plus or minus root over minus 1. This is nothing but x equal to plus or minus root over minus 1 is I. This we learn in complex numbers, x equal to plus or minus I. So here if this is the equation, then if I write this set in a roster form, this will be like this, I comma minus I. But actually they given 1 comma minus 1. So second option is also wrong option. You see here x says that x is a real number. Real numbers means all the numbers in between minus infinity to plus infinity, minus infinity to plus infinity are known as real numbers. Obviously they given only 2 elements now. So option C is also wrong option. Obviously which option is the right option? Option D, because 3 options are wrong means obviously fourth option will be correct option. Here what they given in fourth option, x is a root of the equation x square equal to 1. Here I'll write here x square equal to 1. What is x? X equal to plus or minus 1. You try to understand this. In place of x you write 1 in this, then you will get x square equal to 1 only. In place of x you write minus 1. What you will get? Minus 1 whole square equal to 1, 1 equal to 1. What I am trying to say, plus 1 minus 1 both satisfies this equation. So the roots of this equation are plus or minus 1. You observe here plus 1 minus 1 given. So obviously option D is the right option. What they are asking, the set A is given like this. This is in a set builder form. Is equal to what set? Okay. To do this problem, you must know one property from functions. When modulus of x is less than A, then we can write it as minus A less than x less than A. We have this property. You must know this formula to do this problem. Okay, so here to do this solution, what they given? They given modulus of 2x plus 3 is less than 7. It is of which form? It looks like mod x less than A. When mod x less than A, what you can write? You can write minus A less than x less than A. So what I can write here, minus 7 less than 2x plus 3 is less than 7. I hope you understand. Mod x less than A can be written like this. I applied the same thing for this, right? Now I'll try to get what is x from this. Later we'll check with the options. I'm trying to get x. What is x? Here 3 is there. I don't want this 3. So what I'll do, this complete inequality I'll subtract with 3. Complete inequality you subtract with 3. Minus 7 minus 3, that is minus 10 less than. You try to understand. Complete equation you subtract with 3. Minus 7 minus 3 is minus 10. Okay. Here also you write minus 3. Minus 2x plus 3 minus 3. Plus 3 minus 3 will get cancelled. You will get 2x. What I am doing for this complete inequality, I am subtracting 3. 7 minus 3. 7 minus 3 is what? 4. Okay. I hope you understand this. What I am trying for? I am trying to get x value. So to get x value, you divide this complete inequality with 2. As 2 is a positive real number, the sign of inequality remains same. So here I'll divide this complete inequality with 2. What you will get? Minus 10 divided by 2. I'll write here only. Minus 10 divided by 2 is minus 5. Minus 5 less than. When I divide this with 2, 2 will get cancelled. You will get x here. X less than 4 divided by 2. 4 divided by 2 is 2 only. So I hope you understand. This inequality is there. Na? I divided with 2 for this complete inequality. As 2 is a positive real number, inequality sign remains same. Now you observe with the first option. In first option here, what is there? X plus 5 is there. So what I need here, I need x plus 5. How I'll get x plus 5 here? I'll add 5 to this inequality, and for this complete inequality, I'll add 5. Add 5, what you will get? Minus 5 plus 5 less than, I'm just checking the first option, that's it. In first option here x plus 5 is there, so I'm trying to get x plus 5 here. I'll check whether it is correct or not. For that, what I'm doing, this complete inequality, I'm adding 5. Okay, less than 2 plus 5. Okay, minus 5 plus 5 is 0, less than x plus 5 less than 2 plus 5 is 7. You can easily observe that 0 less than x plus 5 less than 7 we got. Here also same thing is there. So what is the right option? First option is the right option. Now you observe, this is a question given in 2014. In Kcet 2014 from sets chapter, they given 2 questions. Actually this is very easy question. Try to understand what they are asking. In a class of 60 students, in a class total how many students are there? 60 students are there. So here this is the universal set. You can observe your diagram. Here this complete class contains 60 students. This whatever I marked here, what is this? This is 60 students. Okay, and in that they given that 25 play cricket. Okay, n of c. See, look here, whoever the members are there in this, they are 25 play cricket. Okay, and 20 students play tennis. They given that this is the tennis. I taken n of t means number of students who play tennis. They given it as 20. Okay, now 10 students play both the games. They are saying that 10 students play both the games. Here important thing, first point, what I'll do here, 10 students play both the games. Now we know that in Venn diagram, this is the zone where the players will be there, the students will be there who play cricket as well as tennis. As they given 10 students play both the games, this number is 10. Okay, in the question they given that number of students who play cricket, 25 students play cricket. See, this whole circle is 25. If this whole circle is 25, in that 25, this part already 10 is there. So what about this part? This part is 15. It can be understood easily. So that means the number of players who play cricket only, if they ask the number of students who play cricket only, then answer is 15. In the same way, the number of students who play tennis only. Here they given 20 students play tennis. Here this part already 10. We know that this full circle is 20. So what about this part? This part is 10. I hope you are understanding. Right. Now what they are asking in the question, then the number of students who play neither. That means the students who are not playing cricket, not playing tennis. You observe, this is the zone. Please observe, this is the zone other than those 2 circles. Whoever the players are there in this zone, they are not playing cricket, they are not playing tennis also. That means now I need to calculate this colored part. I hope you are understanding. I need to calculate this part. What I'll do, from 60 I'll subtract this whole part. From 60, if I subtract this whole part, I'll get this zone. What is this zone? The number of students who are neither playing cricket nor tennis. So 60 minus of 15 plus 10 plus 10. Okay, that equal to, what is this? Number of students who are playing neither. See, these are objective type questions. No need to write the steps. Okay, so 60 minus of this is what? 20 plus 15. 20 plus 15 is 35. So 60 minus 35. 60 minus 35 is 25. So the number of students who play neither cricket nor tennis is 25. So what is the right option? Option C is the right option. I hope you understand this.
You observe, this is very interesting question. I saw many videos. In all those videos, they not given correct explanation. I'll try to give the correct explanation for this problem. First, we'll try to understand the question. Here, understanding the question is the tricky part. You observe this question, they given A1, A2, A3 like that, A30. Total 30 sets are there, each with 5 elements. In the same way, B1, B2, B3 and so on, Bn. That means how many sets are there? N sets are there, each with 3 elements. Okay, that is okay, clear. Now you observe this, what they given, union of I equal to 1 to 30 AI is given as yes. It means that A1 union, A2 union, A3 union, like that. If you do the union of all 30 sets, then you are going to get the set S. This information they given. This notation is very simple, right? Okay. Now you observe this. Union of Bj, J is from 1 to N, is S. This is nothing but union of Bj's, like B1 union, B2 union, B3 union, like the total how many sets are there? Total N B sets are there. Na? Union of all these sets will gives you S. This notation gives this information only. This is also easy to understand. You observe this one. Each element of S, this is important thing, each element of S belongs to exactly 10 of the AIs. Here many students confuse. Each element of S belongs to exactly 10 of the AIs. What it mean? Actually, here 30 sets are there. Each set consists 5 elements. To understand this, I'll take a small example. I'll take 3 sets. Each set is having 2 elements only. And union of those 3 sets will gives you S. And each element of S belongs to exactly 2 of the AIs. That example I am going to write. Just observe. Okay. What I said, I am going to take 3 sets now. A1, A2, A3. Each set is having 2 elements. Okay. In what way I am writing these elements? Such that each element of S is exactly in 2 of the AIs. Okay. In that way I am writing. I will take example like this. 1, 2, 2, 3, 1, 3. I taken 3 sets like this. What is S? S is union of these 3 sets. Na? Do the union of these 3 sets. What you will get? S is 1, 2, 3. And you observe here. What I considered, each element of S, this is important. Each element of S is exactly 2 of the AIs. Suppose if I take 1 here, that 1 will be in 2 sets of these 3 sets. You see here, first set contains 1 and third set contains 1. This element is exactly in 2 AIs, in 2 sets only. You take 2. 2 is the element of S. Each element of S is exactly 2 of the AIs. Here 2 I considered, na, that 2 is there in 2 sets only, not here. In that way I considered this example. Okay. What happened? I considered 3 sets, each set with 2 elements, such that union of these 3 sets is S and each element of S is exactly 2 of the AIs. Now, in this set S, how many elements are there? In this set S, 3 elements are there. To calculate number of elements in S, we have a formula. What is that formula? Here total how many sets are there? 3 sets are there. Na? I written 3. Each set contains 2 elements. Na? 3 into 2. Divided by, what is the condition here? Each element of S is exactly 2 of the AIs. Each element of S is exactly 2 of the AIs. That means I will divide with the 2. Now, if you simplify this, what you are getting? You are getting number of elements in S. Number of elements in S is 3. This is the formula to calculate number of elements in S. This is the smaller example I taken to understand the things easier. You observe here, what is S? S is union of all these 30 sets. Na? Now, I will try to calculate number of elements in set S. Here, total how many sets are there? 30 sets are there. 30. Each set consists 5 elements. Na? 30 into 5 divided by each element of S. Each element of S belongs to exactly 10 of the AIs. That means you divide with 10. This is the formula to calculate number of elements in S. Okay. Now what happened? This 0, 0 will get cancelled. You will get 15 here. So number of elements in S, we got 15. Okay. Now same like this only, the information related to B's. You observe here, each element of S belongs to exactly 9 of the B's. And you know that union of all B1, B2, B3 and so on, Bn is S. So, to calculate number of elements in S. So, how you will calculate number of elements in S as per this information? Here, B1, B2, B3 like the total how many sets are there? N sets are there. Each set consists how many elements? Each set consists 3 elements. Na? N into 3 divided by, you see here, each element of S belongs to exactly 9 of the B's. Exactly 9 of the B's. That means divide with 9. If you divide with 9, you will get number of elements in S. That is the formula. Okay, now you see here, this 15 is also number of elements in S, this is also number of elements in S. You just equate these two, you see what happens. 15 equal to n into 3, that is 3n divided by 9. Okay, 3 in this 9 3 times. Okay, n equal to 15 into 3. 15 into 3 means 45. They are asking the value of n only in the question. They are asking the value of n. You observe here 4 options are there. We got n equal to 45. So third option is the right option. I hope you understand this class. Dear friends, please drop a like to this video so that I'll get more energy to create many videos like this. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Have a great day. Bye bye.